Welcome everyone from the lunch break. It is time to continue the second day of the conference. And it is my pleasure to invite to our colleague from Statistics Netherlands, Edwin de JONGE, to be a chairman for the scientific session, Dissemination and Visualization. Thank you. Okay, it seems Edwin is not with us right now, but no problem. I'll chair the session in order to continue our program. So in this scientific session, we have four regular presentations and one lightning talk. The first regular presentation comes from Austria. And it is my pleasure to invite Gregor de CILLIA from Statistics Austria to present us building a content delivery pipeline for a website in March. Thank you.
Well, hello. I hope everyone can see my screen. Seems like it's a little bit blurry, so I will restart the sharing process for a moment. Sorry for that.
1 moment ago was okay. Try again, please.
Okay, so maybe just my preview.
Great, thank you.
Okay, good. Then my preview is just more blurry than everyone else's. So thank you very much for the invitation and for letting me open this part of the conference. So I'm presenting building a content delivery pipeline for a website in R, embedding web components from R into a content management system. And to give some background, Statistics Austria is currently working on the release of a new website. And the reason for that is accessibility is not very good in the old version of the website. And a lot of things are redone. And one big change is that R will have a more central role when it comes to graphs and tables that are published in the website articles. And that's what I'm going to talk about today. So the basic setup is that article authors can use a Shiny app to create graphs and tables and then transfer them to the content management system where the rest of the articles are written. So the basic setup looks like this. So we have the component builder app, which is the Shiny application that allows you to import data from 2 different data sources, use this data to create tables and graphs. And after that, the app has some functionalities to export the created graphs and tables into a component database. And what happens then is that the component database stores all the tables and graphs that were created and makes it accessible for the content management system. So we will talk about this more in detail in the following order. First, I want to showcase the app itself and the components to see what's actually being delivered by the content delivery pipeline. The second part will be some remarks about the data import, and the last part is the mechanism that is used to transfer components. So basically the bridge between the Shiny application and the rest of the content management system. So beginning with the components, we are talking here about graphs and tables, and more precisely interactive graphs and tables. So this means that these are HTML, JavaScript based, and provide some kind of mouse interactions. So here's an example of a graph with mouse interactions. So we see a grouped bar chart, and when we hover over the legend, we can see that there are parts of the graph that are highlighted, and when we click on the legend, the graph resizes to skip the part of the data. And there is also a tooltip where we can move over. So most of you are probably familiar with this kind of graphs. So basically it's just more engaging for users to see something like this on web page articles. And it also gives you the possibility to put a lot of detail into the graph and have a lot of data displayed with very little space. And similar idea is for the tables. So this would be an example of an interactive table where we show 36 different employees from a company, and we can just step through the data and show 5 entries at a time. We can sort the data, we can do some filtering, etc. So again, the idea is to make it more engaging, but also to just show a lot of data with very little space. And with that, I want to come to a live demonstration for the web application. So here I have the graphical user interface, which I called the component builder app in the past. So this is where the graphs and tables can be built. And we see here we are in the importing screen. So this is where we define our data source that we want to use for the visualization of the table. And currently there are 2 data sources. One is to define a JSON that was exported from something called StatCube, where we can provide some custom data. The second thing is open data import, where we can import data from the open data portal of Statistics Austria. So as we can see, there are currently about 300 different data sets available. And the third one, which I will use for this demo, is some examples. So these are example tables from StatCube. And more precisely, I will define the labor force survey example as my data source. And as soon as we hit import, we will see on the right side a summary of the data set. So this data set basically has 2 different measurements for the amount of hours worked per week. And there are also some classifications. One classification is the time variable, which gives a year between 2015 and 2019, a gender variable, an education level, and the NUTS2 region of Austria. And now we can go on and use this data to create graphs or tables. In this case, I will showcase the graph generation. So here, if we switch to the graph, to the visualize part, we will see a bar chart, which is automatically generated. And now we can use the controls on the left to modify and customize the charts. So one thing I will do here is to switch the language to English to match the presentation language. And as we can see now, the axis uses time section, so an English label instead of a German label. So German is the default, but both StatCube and Open Data provide all the labels in English as well. And what we can do now is to further customize it. So I can say use the NUTS2 regions for the X variable, use the gender for the color variable, and use red in the color palette to switch the colors for the female. So this is the basic idea. It should be very intuitive and easy to create and customize the graphs. But we also want to make sure that the layout is publication ready and everything is consistent with the corporate design of Statistics Austria. Once we are happy with a graph, we can go on and export it. But before, I want to say there are different graph types and options that I'm skipping here. So once we are happy with a graph, we can go to the export section. And here we see a listing of several graphs that I created in the past. And what I can do now is just to provide a label for the graph, hit save, and add it to this list of graphs, which means that it's going to be added to some database. And when I want to use a graph or a table inside the content management system, I can just copy paste this idea here, this identifier, to import it into the content management system. So go back here. So this is the basic idea of the Content Builder app. It's a Shiny application which is hosted on RStudio Connect, and it just guides the content creator through the whole process of generating and exporting graphs. There is imports, there is some GUI to create graphs and preview graphs, and a very easy to use export menu. I also included a demo video inside the slides if you want to look at yourself. It's basically the same that I just put there as a live example. So now that we've seen the front end of the project, I want to talk a little bit more about what's happening in the background. So currently there are two data sources which are compatible with the Component Builder app. It's StatCube and Open Government Data. And all the logic for the data imports was bundled into an R package called StatCube R. And the StatCube R package is available on GitHub, so you can install the package with one line of code. And if you have if you're interested in the details about the data import, there is also a GitHub Pages site which provides HTML documentation about the package. Now about the export mechanism. So as we've seen in the live demo, there is the export section inside the graphical user interface, which allows you to save the graphs and tables inside a database. What's happening here is that the Component Builder app will basically bundle the graph and table that were created from the user and send it to the component REST API, which is an API that we created with the plumber package. And the component REST API then verifies if the graphs and table have the right structure. And if so, the REST API will put the graph and table definitions inside a component database. And if, on the other hand, the content management system wants to import a graph or a table, so basically the user provides an ID for the graph and the table, and the content management system then sends this ID to the component REST API, and the component REST API will pull out the corresponding resources from the component database, apply some rendering logic, and then return the rendered version of the graph or the table to the content management system. So this has several advantages. Because the graphs and tables are rendered from the API, the content management system doesn't really need to know the details about how the graphs and tables are created. It basically just receives some template strings that can be included in the website articles. And with that, I want to come to the conclusion slides. So in this project, we use the Shiny package to create the front end for the whole delivery pipeline, and the Plumber package to create the REST API, which serves as a bridge between the app and the rest of the content management system, and also handles the database. And those are pretty much the standard packages when it comes to web application and RESTful APIs. For the front end, we used two JavaScript packages, the HighCharts package for the graphs and the datatables.js package for the tables. And in the backend, we also used other packages like the HTTR package to communicate with the REST APIs. And the StatCube-R package was specifically designed to perform the data import. And as I've mentioned before, the StatCube-R package, which is responsible for importing the data and providing the data that will be used during the visualization process. This package is available on GitHub and can be installed and used by everyone. With one important limitation, however, currently the REST API of StatCube is only available inside the Statistics Austria firewall, which means that external users will not be able to import StatCube data with StatCube-R, which means that the package can only be used with open data as a data source. But there are plans that the REST API will become available for external users soon. And as soon as this happens, we will make sure that StatCube-R will be released on CRAN and become part of the official R ecosystem. There are also plans to open source other parts of this project. So currently we have 4 internal projects which are used by the app. And one of those internal projects packages is the StatGraph package, which is responsible to define the layouting of the graph and basically set the configurations in a way that HighCharts, the JavaScript package, understands. And this part of the project is very likely to become an open source package. And the same is true for the Stat table package, which is responsible for all the layouting of the data table components. Other parts of the project are less likely to become open source. The app itself is very tightly bound to the to our internal infrastructure, and we would have to put quite a lot of effort into it to open source this, but it might happen. And with that, I thank you very much for your attention. Have a nice afternoon.
Thank you for your contribution, Gregor. Very interesting, and good luck in your work. I see there are no questions in the chat, so we may go on with the next presentation from Spain. Mrs. Sandra Barragan, I will invite her to present us joint authorship Romania and Spain about a package named simviz. Please, you are welcome.
Thank you. Can you hear me?
Yes.
Can you hear me? Okay. Yes, I'm Sandra Barragán, and I'm going to present simviz, a package to visualize simulated telecommunication mobile network event data. But the most important part of the presentation is not really in simviz, but in another package, simutils, which we have implemented to gather all the previous steps to reach the visualization stage. This is a work between two members of the Romanian National Institute of Statistics, Bogdan OANCEA and Marian NECULA, and two from Statistics Spain, David Salgado and myself. I want to thank all of them for the great effort. This presentation consists of three main points. First, we will see agent-based data simulation and the network event data simulator. Then the execution pipeline to manage and visualize the inputs and outputs of the simulator, and finally, some graphics. Here we can see the approach, which is new in official statistics, that uses agent-based data simulations to develop the production framework. In the past, the idea was to follow a linear process, where the first step was to access the data, and then developing the methodology. But if you cannot access the data, you are facing serious problems. Now, this approach is about having simulated data that represents the real data. So, even if you don't have access to the data, you can develop the following steps. This manner is even better because you can simulate the reality and obtain the data about that reality, so you are able to test the methodology and evaluate its quality thanks to the knowledge of the ground truth. The real challenge here is to incorporate the metadata about how reality works to the simulator in order to have a good representation. If you have those metadata and a simulator, then the legal issues are solved. The costs are highly reduced. There is a huge advantage because you know the ground truth. And finally, thanks to the tool, you can change along a full range of different parameters to test the behavior of the methodology. In this specific case, the parameters that we can change are the mobility patterns, network configuration, and the territory. So the important idea is not exactly the simulated or also called synthetic data itself, but the tool to generate them and having multiple and diverse data sets. In this slide, I show you the mobile network data simulator, which has been developed in C++ language in the context of the European project SNET on Big Data and is available in GitHub. This simulator has a set of input files in XML format apart from the map, which is in WKT format. These files have the information about the simulation, time information, the type of mobility, the probabilities of having a device and a second device, Also information about the persons, such as how fast they walk, how many people are, how much time they spend at home. Also about the map of the territory, about the antennas, their positions, their power, their parameters, about the signal strength, and also which even location probabilities you want to compute. Once you execute the simulator with these inputs, you can obtain these outputs. The grid, which is in which the territory is divided, the ground truth about the persons, their positions, and their devices. Also, the information about antennas with the positions, the events arising from the connections of the devices to each antenna at each time, the coverage area of each antenna, the signal strength of each antenna in each part of the territory. And also, if it is specified, you can obtain the event location probabilities, as you can see in this animation. I want to mention also that all these files have their dictionaries in XML and their corresponding XSD files to be able to check the coherence in the names and types of variables. Now you can see the execution pipeline to deal with all the information related to the simulator. Although the simulator has been implemented in C++, all these steps are implemented in our language. So these two packages, simutils and simviz, allow you to execute the whole process in R. Both packages are available in GitHub. Now, the first step is to specify the inputs with the updates in input function. Then you can run the specific simulation with the run.exe_file function. At this point, you need to have installed previously the simulator in your computer. Due to current requirements, it is not allowed to have executable files in the package. So the easiest way to install the simulator in your computer in Windows is to download the installation kit that is in this link, and then you have the simulator and you can run the simulation, the specific simulation with run.exe_file. Then you can read the outputs with the read simdata function and obtain some aggregates of the ground truth with these functions, compute total and compute OD matrix. You can obtain the total population counts and the origin destination matrix. These outputs can be visualized with the simviz package, which is the final aim of the presentation. But as you can imagine, it is much more challenging to have the information perfectly organized with the adequate geospatial objects, which is really done by simutils. Once these objects are built, the visualization is straightforward, and you can have the input-output graphs for the map, the individuals, the grid, the coverage, and the network, and also some graphs for the aggregates. Although this part of the aggregates is still in development, so I will show you in this presentation the representation of the inputs and outputs. But first, let's see some information about the software. Here you can see the relations among the functions of simutils package. In green, you can see the main functions that you will call to follow the pipeline. The workhorse here is the output of read simdata function, which is a list of 5 elements that are spatial objects from stars and SF packages, used to represent the territory in the map, the network information, the coverage of each antenna and their signal strength in the grid, as well as the ground truth about the individuals. In this slide, you can observe the packages dependencies of SIMutils, mainly two types: data management, such as data table, and spatial packages, such as stars or SF. And finally, the graphical results. All the results shown here come from a specific simulation of a sample territory divided in 4 regions and 10 sub-regions, with 70 antennas and 500 persons, moving around the territory with 0, 1, and 2 devices. In these two plots, the regions and sub-regions are represented with the simplot territory function of the simviz package. I want to remark here that all this information about the territory is organized in spatial objects of class SF, which allow you to obtain one or another depending on the aggregation you prefer. In this grid of plots, you see the information of 70 antennas, their position in the map, their signal strength, and the coverage area. This grid has been plotted with the simplot network function of simviz packets. And this is a zoom done for the antenna 18, just to visualize better. Here you have the information about the ground truth, which is known if you only have simulated data, because if you have mobile network data from real data, you can not know this information. In the first plot, done with simplot individuals function, you can observe the positions of all the individuals at time 0, and the colors represent the number of devices that they are carrying on. And as the simulator is executed for a period of time, you can see in this animation the selection of 2 individuals and their movement along the time. This animation has been done with SimAnimate individuals function of simviz package. Notice that we have now in development the graphs of the aggregates to be incorporated to this package. Related to the future work, you can see here the big picture of the whole process, which goes from the raw data in the bottom to the population counts and the origin destination matrices on the top, along a fully modular process. The methodology framework of this process has been developed in the European project called SNET of Big Data, mostly in R, with some preliminary prototypes for each process step. The goal now is in a general improvement of all these packages, leaving for future work the issue of scalability. That's all, and I want to thank you for your attention.
Thank you for your presentation, Sandra. Very interesting. And good luck to the team in developing this great work. I see there are no questions in the chat. So we may go on. I propose to go on to the next presenter from Germany. The presentation is entitled Modern Graphics for Presenting the Results of Life Events Surveys on Satisfaction with Public Administration. And the presenter will be Mr. Daniel Henrik from the studies. Welcome.
Good afternoon. Thanks for having me. I share my slide. Just a second. Here we go. Yes, my name is Daniel Kühn-Henrich, and I'm working for the Federal Statistical Office of Germany in the field of better regulation. And together with my colleague, Ms. Silvana Walbrecht, we will present to you some of the graphics we used to present survey results on the satisfaction with public administration. But before I'll show you the graphics and the underlying R code, I will give you a brief background about the survey. As I mentioned, it's a survey on the satisfaction with public administration, and so we ask citizens and companies to evaluate their level of satisfaction with public authorities. This survey is part of the federal government's program on better regulation, and we started to conduct these surveys in 2015, and the results I'll show you are those of 2019, which are the most recent ones. You can find all the results on amtlicheinfach.de. Unfortunately, only in German, but for this presentation, we have translated the graphics into English. Okay, so let's start with the first of three graphics we used in our publications, which is a word cloud. We used this word cloud to illustrate answers on open questions. So in this case, you see the categories of answers given by citizens who were dissatisfied with the service they received at public authorities, and what they answered when we asked them why they are dissatisfied. These answers were classified, and the word cloud represents the frequency of complaints, issues, problems mentioned by citizens. So the most important or the most pressing issue is the processing time, which is also displayed in the biggest font. That means that citizens frequently complain about the long duration between the application and the decision by a public authority. And then you can see other issues like complicated procedures, waiting time, lack of competence, which were also mentioned frequently. But as smaller the font is, the lower the frequency of this issue was mentioned. Now, I'll show you the underlying R code we used, which is quite simple, to be honest. We use the R package word cloud 2, which contains the command word cloud 2 and requires a data frame which contains in one column the words or the categories you have seen in the word cloud, like processing time, waiting time, and so on. And in the other column, you can the frequency is defined in ordinary numbers. So this data frame is basically the data which is at the end displayed in the word cloud. The other arguments are basically for the other design functions, starting with the color. As you might have seen, the bigger the words are, the darker these words are also. So the smaller words are also a bit lighter, and that's what we defined in this color argument. In this color argument, we defined the different shades of blue in which the words are displayed. Then we have the background color, which is obviously white. You can also rotate the word cloud if you want, but we choose to have it horizontally, so the rotation ratio is 0. We used our corporate font, and then you have several arguments to define the size. But in total, this is quite simple, the command to create these type of word clouds. For the export of the word cloud, we use two different packages. One is WebShot and the other one is HTML widgets. And with one single line of code, you can export the word cloud into an HTML file. Unfortunately, it's not possible to export it in a different format like PNG or in a vector graphic. So we had to convert the HTML file into the needed format, but still it was quite simple. This export function is quite simple, as is the word cloud itself. For the more fancy and more complicated and complex codes and graphics, I will now pass on to my colleague, who's our expert in programming and coding, to Ms. Walbrecht.
Thank you. I think this is a little bit too much said, but if I listen to the other lectures, but we will see. Maybe this is of interesting still to some of you. So glad to be here. This is a network diagram. We already have seen some network diagrams before, but this is some other kinds and maybe also interesting. So we have here the nodes, which are the authorities in the live event birth of a child in Germany. So you have to contact these authorities, at least some of them. This depends on which things you want to apply for. And you see here are some lines between these nodes, and they represent the frequency of the combination, which means the thicker and the darker the line, the more possible it is that you have to contact both of these authorities. For example, contact to the registry office and the parental allowance office is more frequent than the combination of JAWS welfare office and job center. Daniel, can you please go to the next slide? Thank you. This is the input data set. It contains the names of the authorities and the frequency of the combination. Here in this example, we also have we only have the combination frequency. It would also be possible to show how frequent contact to one authority is, but this is not used in this example. On the next slide, thanks. You see the R code. We use the package iGraph, and this is also, I think, very easy. First, we open PDF to write the graphic into it and define the spaces on the sides of the graphic. But this is here not so important. And then we have to define the edge list. So it contains the variables with the names of the nodes to be connected, and then also the weights, which means here the frequencies. And on the bottom of the page, you can see that we also assign different colors and thickness of the lines depending on the frequency values. Then on the next page, it goes on. The plot function, there you just have to name all the information, the edge vector and the color vector, and we also give our corporate font. And yeah, you can define the aspect ratio if you want to. Yeah, and the dev off command just closes the PDF. And that's it. For further information, you can have a look at the official documentation of the package. And there's also a very good page where with even more examples. I said that it's also possible to have different thickness of the nodes. And for example, this is shown, how this works is shown at the second page. Now we come to another kind of network diagram. This is a special type called Sankey diagram. I think many of you have seen it before. So we also use this in our application. This one is for showing if it's related, what kind of media the people use privately to go on the internet, if this is related to how they fill their forms when communicating with public services. And you see that most people have PC or laptop or use smartphones, but still most of the forms are filled based on paper. 34% in 2019, which is a lot, and this is for Germany. So this is a really interesting example. And the code is, or the data is shown on the next page. You need 2 data sets to create this Sankey diagram. The first one contains the again, the nodes to be connected on the left and right side. And the second data set contains the link information. Each node gets a number, as you can see on the left page. And in the link data sets, you have to state which nodes represented by these numbers have to be connected, and which is a frequency value for it. And you can also give a group name, for example, coloring. On the next slide, there's the programming code. This is a vector is here defined for color by group. So each node has a different color, and each link also. The colors correspond to each other between node and link, but the transparency is different. The links are a little bit lighter. And it goes on the next page. You need the network D3 program, and the code to start it is shown there. You have to give in the dataset names containing the nodes and links, and the variable names which are needed. Can also define the font family and size, and other thing like color and node width, and the group variables. Yeah, and that's it. Again, relatively easy. And there's also a very good documentation on this on the official page, but also there are different sites with other examples. These were our R examples for graphics. Most of the graphics have been implemented in SAS, and we have used them for our print products. But in this year, we have just internet graphics, which are implemented by high charts, which was also named in the lectures before. Maybe I can briefly show you this, even if it's not really related to R, but maybe interesting. So this looks like this, and this is our new kind of graphic. So this was just for 2019, the graphics in R. So thank you for your attention. We hope it was interesting, and looking forward for the other presentation.
Thank you, Silvana and Daniel. Very interesting indeed. And the graphs looks great for visualization of indicators. Good work. I see we have no questions in the chat. Then I propose you to continue with the next slides from Poland and Turkey. It's about an art package for gathering and analyzing Turkish higher education statistics. So I invite the speaker, Mustafa Kavus.
Hi, Anya. Hello. Just a second to share my presentation. Hey, everyone. I guess you can see my presentation. Hello, everybody. I am Mustafa from Eskişehir Technical University Department of Statistics. Now I am working at Warsaw University of Technology as a postdoc researcher. Today I will talk about our studies titled as the Stats and our package for gathering and analyzing Turkish higher education statistics. This is a joint work with my colleague is Olga Naydın from Gdansk University of Technology. The outline of our presentation consists two main parts. First one is about our motivation, higher education system in Turkey, and the effect of higher education in Turkish economy, which is presented by me. And the remaining part is about our data source, uses of our package, some demo and results, which is presented by my colleague Olga. I want to start with the motivation of our study. As you know, the open data is one of the most supportive components of the research for transparency, reproducibility, and so on. Making the data open or easily accessible has gained momentum in recent years. And also there are some R packages to provide researchers to query and analyze open data from various data sources by scraping web pages or using APIs. Our study focused on open data of higher education in Turkey because there are many research studies in the literature focusing on higher education statistics in the world to answer two main questions. These questions are how to analyze the higher education entrance exam and how to understand the reasons behind the university preferences of the students. Of course, there are similar research studies conducted in Turkey. I want the three of them to you today. First one indicated that the majority of young people prefer to study to have a job in health, engineering, and teaching domains, as those domains offer relatively better employment prospects in Turkey. And the second one examined the socioeconomic backgrounds and preferences of the science high school students regarding transition into higher education. The last one pointed out that the higher education entrance exam is one of the sources of anxiety among young people in Turkey. So, as seen in the studies, the higher education statistics are interesting in Europe, also in Turkey, but the topics related with higher education are more critical in Turkey because the number of bachelor students in Turkey is over 4 million, according to data from 2018. This is highest in the Europe, especially when we compare it with Germany, which has close number of population with Turkey. We see that there are 2 times more students from the closest country. So we can say that this statistics makes the higher education more interesting in Turkey, as we know that it is one of the most important components of the local and also national economy. So, when we talk about higher education statistics in Turkey, there is a authorized council, is Turkish Higher Education Councils, provides a web portal to share higher education statistics of Turkey, but it does not offer any possibilities to download or query data in a comfortable or tidy way. And we think that it is not user-friendly and cannot be communicated with any analytic tools such as our Python. So we decided that because of this problem, we need to implement an R package to provide these data sets in tidy way by scraping this web portal. So this is our motivation behind our study. Now I want to talk about a bit higher education system in Turkey. It is administered by the Council of Higher Education, which is an autonomous institution that is responsible for planning, coordination, and governance of higher education in Turkey, of course, under the Turkish Constitution and higher education laws. There are 3 cycles of higher education. These are bachelor's, master, and doctoral studies. Our study focused only the data for admission to the first cycle, which involves from 4 to 8 semesters or more, depending on the field of study. And the Turkish higher education admission procedure is nationally standardized, and universities may use criteria for a further selection of applicants. So, a student wants to enter the higher education system in Turkey should pass 3 steps as you see in here. First one is graduation from any high school. Second one is basic proficiency test, which conducted once a year to measure the basic skills on grammar, social science, mathematics, and science. Every student who pass a threshold score in this exam can take the next exam, which is named as field qualification test. Consists the subjects relevant to preferred major field of the study, with the score calculated at the end of these 3 stages. Students apply to universities and are placed by the authorized institution. So, what is the effect of higher education on Turkish economy? I want to highlight that real estate is one of the most important elements of the Turkish economy because housing is seen as a key and traditional investment. We can say that it is possible to see the effects of higher education on the real estate sector as they are connected with the migration of students between different cities and different regions within the country. And we have a network plot. You can see right hand side this. We see that there are many thousands of students migrate between regions in every year. In addition to the housing sector, we can say that the migration of students also activate the fast food, transportation, and entertainment sectors. So now Olgun will continue and he will show us some demo and practice in R. Olgun.
Okay, so thank you, Mustafa, for the introduction and the information you shared. Hello, everyone. My name is Olgun Aydın, and I'm assistant professor in Gdansk University of Technology. You know, Mustafa already mentioned our motivation, and also how Turkish higher education looks like, and also what type of effects we can observe, effect of higher education on the national economy. And then he mentioned about real estate. So you might consider it maybe and say that we are overreacting, but the numbers are showing us that, you know, before university starts, so universities usually starts in Turkey around September, but when we look at the rental increase in the rental prices in the metropolitan areas, like the biggest cities in Turkey, and then you can see like 100%, 120% increase on the rental flat prices. So I mean, this is quite interesting and quite amazing, and even some cities are actually developed thanks to the universities. So you know, they are opening universities if this university is very well developed, and then afterwards you can actually observe that city is growing towards there and more students come, and you know, they need also they need to sustain their lives, and then they also you know, contribute to the local economy, you know, by just buying and going to the shops and so on and so forth. So yeah, based on that, and so we actually realized that this Higher Education Council is providing amazing data set, but unfortunately this is not user friendly. I mean, maybe just browsing the data is pretty okay, but it is not so easy to get this data from this portal and then you know, apply some statistical methods on the top of that to understand or to have like a better outcomes out of this data. So based on that, we decided to build a package, and we call it as the Stats. So it stands for Turkish Higher Education Statistics. And so this package allows researchers, users, or who are interested in Turkish higher education to just query this data, and without having, or without basically having worried about how to get the data or how this data should be crawled from this website and so on. So how we approach to structure the data. I will show you in a moment and how this web portal looks like and how actually painful it is to get this data from there. So what we are doing, so we are scraping this data using RWES package, so which is actually a very powerful package when it comes to scrubbing the data. And then so we basically, so for the first version of the data, we got the data from this portal for 2018, 19, and 20. And then the data is there. So then afterwards, we created our functions, and then afterwards we created our data files, and thanks to use this package. And then this package is actually a very helpful package for handling creation of the R data files. And then you can wrap this R data files into an R package very easily. So in the next, yeah, exactly. So thanks for the comment. So actually, our package is very straightforward. We didn't want to, you know, make the things complicated for the researchers. We decided that we just need to provide some fundamental functions. So then we decided, and after like really long conversation, you know, after like a few weeks, and then we decided, okay, let's stick with 3 functions, and then those functions allow researchers to have data and then to query the data. So query and then also even have some aggregations. So for example, this list unit function is allowing users to pull data regarding the university in the university level. And the list Dept function is even more detailed. It helps researchers to get information regarding the departments in the universities. And the list score, then this is the, I think, I mean, my favorite one, I would say, because then thanks to this function, you can get all the statistics in the level of department, in the level of faculty and university. So now I would like to share my screen, and Mustafa, if you don't mind, so if you could close, and I will share the screen. So let's say, so I'm sharing the screen. Can you see it? Perfect. All right, so this is the portal. This is how the portal looks like very quickly without actually making you overwhelmed. Unfortunately, it's in Turkish, but I will like quickly describe and I will show you how overwhelming it is to get data from this portal. So first, a researcher or a student is coming here and selecting a university. And then let's select a university. This is a university from the west part of Turkey. And then the portal lists the departments. So let's go and select statistics. Then afterwards, it provides very useful statistics and very useful information here. But as you can see here, where each tabs, you know, are in the sort of kind of a drop down. Not like I think it's called hamburger menu, but anyway, I'm not sure about that. So when you click each of them, you can get very useful information. So this is the data, for example, which shows the gender distribution. So this data shows the geographical distribution in terms of from which regions students move to Izmir to study in this department. So as you can see, the data is here, amazing and very valuable, but unfortunately, it's not user-friendly to get this data. Even as you can see, no button or nothing which can help us to download this data. So after giving you some background, and I would like to present, just run this package and then just, use those functions and I will try to give you some insights. So I was mentioning about those three functions. So I prepared here some examples, but of course we don't have to go through all of them, for the sake of the time. And so I don't want to also take so much of your time. All right, so this list unit function has some arguments. So region names, we can define any region. And we can just define only a city. And we also are offering language option to the researchers. So basically, researchers also can decide on having the data either in English or in Turkish, because we thought that foreign researchers, researchers from outside of Turkey also would like to perhaps work on this data. But of course, we thought about Turkish researchers because, probably they would be most likely interested in that. So we actually decided to offer two language section. So two language options. So basically, whenever we run this function, so basically, in this case, what we are getting the name of the universities from Izmir. This is the city on the west side of Turkey. And then we can see the type of the universities and then their region and then website information. As you can see here, we have like state public universities and private universities. But what if we want to see universities in multiple cities, and then we are just passing a vector which contains like multiple city names. And then in this case, we are able to see the university names in multiple cities. So what if we want to see the university names in a geographical region? So in Turkey, we have 7 geographical regions. So the Central Anatolia, as you can probably realize, it's the center of Turkey. And so if I just pass here the name of the region, as you can see here, you can even decide on the name of the region. Either you want to go with English one or you want to go with the Turkish one. Of course, we also paid attention to Turkish characters because in Turkey, in the keyboards, we have Turkish characters and so on and so forth. So just to avoid the confusion. So let's see, University Central Anatolia in English. So yeah, I'm now able to see all of those universities in Central Anatolia. Okay, so what about the aggregation? So what if I want to see number of universities per city in one specific geographical region? For example, let's assume that we would like to see how many universities are there in each city of Central Anatolia. Then also we will see here actually those aggregations in the level of type of the university. So here we go. As you can see in Central Anatolia, we got 17 private universities and 26 public universities. So this is helping the researchers to have like very quick insights, just not going into details and then running any type of aggregation. So in terms of list Dept function, and then here we are able to get data in the level of departments. So for example, here we can say, okay, just give me information about the universities in Izmir and Muğla, and then which have statistics department. So in that case, and then here we are able to see the name of the university and then faculty name, and then also we are able to see also the official ID of the program and official ID of the faculty. So what if we want to have some aggregation? So for example, if you would like to see these aggregations in the departments level and also for some specific region. So let's quickly take a look at this. Just let me see. Yeah, I think this one. And as you can see here, we are able to see in Ankara, which is capital, we got like 13 private university and 8 states public university. And because Ankara is in the central Anatolia region, so that's why, for example, here we cannot see Istanbul as it is in Marmara region, the different region. So quickly showing you the last function, and so then I think it will be time to conclude the speech. And the list score function, and here actually we are able to provide more information. And so here the user is able to pass the name of the region, name of the city, name of the university, name of the department, and even ID of the variable. So those variables, actually those things that you see here. So for example, like number of students coming from Marmara region. So things like that. So those variable names were so long, and then we decided to give them ID, and then we also share additional table where they can map those IDs with the actual name of those variables. I mean, this is for researchers, and we provide it in 2 languages, Turkish and English. So for example, here, let's just take a look at this example. And X189 is basically pointing out number of associated professor, and X190 is showing us number of assistant professor. For example, let's assume that we would like to see how many assistant professors and how many number of associate professors are there in the statistics department in Izmir. So in the universities which are located in Izmir. Oops. Yeah, curse of demo. So, so here basically, as you can see here, but it's already generated. So as you can see here, and also we can see the statistics per year. So for example, in 2018, basically in Izmir, we got like 2 public universities which have statistics departments, and here we are able to see this statistics. So for example, in Ege University in 2018, there were only 4 associate professor, but then 1 more joined the squad, and then afterwards, so nothing changed. But for Dokuz Eylül University, and then, so there is a sort of a decrease in this. Of course, we allow researchers put here as many variables as they are interested in. So then thanks to that, they will be able to have more information regarding universities, departments, and so basically we didn't want to limit users here. Then that's why we didn't want to provide also like more functionalities in terms of aggregation and so on. So basically we provide the data, and we provide them possibility to query the data in a very easy and in a user-friendly way. So
please try to conclude. Thank you. Olgun?
Sorry, I muted myself. I'm sorry. So I think this is pretty much everything. Can you hear me now?
Yes, yes.
Okay. So yeah, pretty much everything about the data and usage of the data and how we can use it and so on. And so we can maybe quickly mention that we already submitted this paper to a journal. So it's already in review. So then afterwards we will submit it to CRAN, and soon we will make our GitHub repository also public because it is under review. So that's why we wanted to keep it private for a moment. So then we will make it public, and then your feedbacks and also your comments will be very valuable for us to improve our package. And in the future, of course, we will try to maintain this package, add like updated data, because this data on the portal is updated annually, and then we will try to keep it up to date. So then we also consider of adding some like visualization functionality to this function. I think that's pretty much everything. Mustafa, maybe you want to add something.
Thank you, Olgun. I think it is enough.
Yeah, exactly. We covered many topics. Yeah, exactly. So thank you for your attention.
Thank you. Thank you to both of you. Congratulations and good luck in submitting to CRAN and the next steps in your research.
Thanks a lot.
Great.
Thanks a lot.
Thank you.
And bye-bye.
Okay, now we'll move on to the last presentation of this session, which is a lightning talk of 5 minutes from Netherlands. I invite Mr. Marco Ramjak to present us about spectral density estimation based on mobile network data. Welcome.
Hello, and yeah, thank you for the invitation. Can you hear me and see my slides? Yes, okay. Okay, so welcome to my talk. My name is Marco Ramjak and I'm an EMOS master student at Utrecht University. And today I will present my MNO analysis workflow that can hopefully help you with your next MNO spatial density estimation task using the static approach within R. Compared to the dynamic approach, which was presented earlier with the title simviz, the static approach only considers aggregated cell counter data. Both approaches are still under heavy development, and at some point one should compare both approaches, but this is not the topic for today. Why do I think is this workflow relevant for other researchers? Well, within this topic, we are in need of further research concerning estimation methods, and this requires the development of non-trivial software. This workflow supports you exactly with this by consolidating and extending many relevant resources the open source market has to offer. Let's look at the structure of the workflow. We have 3 modules: generation, estimation, and evaluation. Each module is independent of each other, meaning I can start and end the workflow with every module. Also, you can use the workflow with any kind of data availability: completely synthetic, semi-synthetic, or fully real data. However, the real functionality lies when you do a whole or a semi-synthetic simulation. The first module lays the groundwork and handles all the data generation. Here we create our truth population in our operating area and parameterize our required network with as much detail as we want. The heavy core of the radio propagation modeling is done through the Great MoBlock package. Then we bring the ground truth population and the network together and initialize our phone to cell association function that creates the aggregated cell counters based on a generative model. With the main output objects from this module, we move on to the estimation module. Here we offer code for all state-of-the-art estimators, deterministic as well as probabilistic. The idea is that new estimators can be integrated here, or to create and test specific model specifications. The main output is an estimation vector of each estimator function that is directly comparable to the ground truth. These are exactly the inputs necessary for the last module, the evaluation. Here we investigate the similarity between the estimation and the initial ground truth of the phone density. The most important evaluation metric I want to point out is the Kantorowicz-Wasserstein distance, which takes the spatial nature of the estimation task truly into account. For this, we use the convenient function compare one-to-many within the spatial KWD package, which was also presented already today by Stefano Gualandi. At this stage, also other metrics can be, of course, integrated, but we count on the KWD currently. To give you a practical example, let's take a look at how this workflow is applied in my current research project. From prior research, we know that probabilistic estimators perform better than the traditional Voronoi methods. However, we only have evidence if perfect cell information is available. In my thesis, I investigate the estimator's performance when we are uncertain about the available cell information. In this project, we initialize the workflow by using real census data from a part of Germany containing around 160,000 grid tiles with a square meter size of around 100 and around 1.7 million phones. We generate multiple different networks to test everything under different network topologies and create the respective cell count vectors. In the estimation module, we test all available estimators. However, we specified different estimation models, as you can see here. These models differ in the level of mismatch we purposely implement. For example, one option is to introduce spatially sensitive random noise, which, as you can see, distorts the cell footprints to different degrees and creates coverage holes. All estimated versions are then subject to evaluation. The KWD values reveal that even severely mismatched models lead to more accurate results than any Voronoi method. The results of the whole study, where we also look into further mismatch options, such as quantization, and the impact of mildly informative priors, will be reported next year. Thank you very much for this opportunity. And here you can see the most used packages. And I want to point out again the spatial KWD package and the MoBlock package, which work very perfectly. And I'm very glad that I can integrate these into this workflow. Thank you very much.
Thank you so much, Marco. Very interesting. And good luck in your work. I see we have no questions. So I propose to move on to the next scientific session, which is the ARI production about automation. And I'm inviting my colleague, Mark van der Loo from Statistics Netherlands, to chair this session. Thank you.
Welcome everybody in the afternoon session on automation. We are a little bit over time and we have 1 hour for 3 regular talks and 2 lightning talks. So I'd like to ask the presenters of regular talks to keep their talks in 15 minutes. And then we can still do everything in 1 hour and have a coffee break afterwards. Our first presenter is Yukaku Toko from Japan, and she will talk to us about autocoding based on multi-class support vector machine by fuzzy C-means method. Floor is yours.
Thank you, Mark. I'll share my slides. Can you see my slide? Okay, so hello everyone. So I'm going to talk about autocoding based on multi-class support vector machine by fuzzy C-means method. So the Family Income and Expenditure Survey is a sampling survey related to households' income and expenditure. In this survey, households are asked to keep their daily incomes and expenditures into family information file as received digitally. The information from respondent family information file includes purchased item name or receipt item name in short text descriptions in receipt digitally. And using those information, we assign a corresponding code for each item. Then we use the coded information for efficient data processing, create result tables. This is coding task. So for the coding task of the Family Income and Expenditure Survey, we have developed an autocoding method, which is a reliability score-based Bernoulli type simple Bayes model. In this model, we improved the Bernoulli type simple Bayes model, which is one of naive Bayes, by introducing fuzzy measure as a reliability score. And the improved method performs well, and it will be practically implemented in 2022. However, it is well known that the Bernoulli type simple Bayes model does not perform well for large amounts of complex data, where the data of the Family Income and Expenditure Survey included text description that extracted from receipt digitally is getting large and complex. So therefore, in order to obtain stable result of discrimination as coding with high generalization performance, dealing with cognitive uncertainty for text description data, we propose a new autocoding method, which is a combined method of support vector machine, SVM, and fuzzy C-means method. The proposed method utilizes both SVM, that is a machine learning method known as high generalization performance, and fuzzy simviz method, that is a computational intelligence method known as high performance dealing with cognitive uncertainty with linguistically motivated computation. And in our previous study, we developed a hybrid method of SVM utilizing word-to-vec and the previously developed classification method based on the reliability score. However, in this method, we simply applied SVM to whole given data. Therefore, there was a room for more efficiently classifying of those data to improve the classification accuracy. Therefore, in order to improve the accuracy of the result of the SVM, we have proposed a hybrid method of multi-class SVM and classification method based on reliability score. We utilize a clustering method before applying SVM to capture significant feature of data. And based on the captured feature, we apply SVM individually to each data included in the corresponding cluster. The merit of obtaining several groups before applying SVM is that we can apply SVM individually to each group considering each group's discriminable ability. So we combine such a function with the previously proposed hybrid method of SVM utilizing word-to-vec and our previously developed classification method based on reliability score. However, our recent data is obtained as received digitally, which include complex representation of text descriptions. So our study's significant feature of today's talk is the inclusion of fuzzy clustering as fuzzy simviz method in order to obtain stable results dealing with cognitive uncertainty for text description data. So fuzzy simviz method is a method of computational intelligence. Computational intelligence is linguistically motivated computational paradigms, theory and design of fuzzy logic, neural networks, and evolutionary computation. And here is an overview of the proposed algorithm. The above flowchart shows the classification method of SVM and FCM. First of all, we tokenize the data utilizing Japanese tokenizer Sudachi and obtain numerical vectors corresponding to words, applying word-to-vec. It is a well-known method to produce word embeddings. Then we classify data into C clusters applying FCM. In this flowchart, we set the number of clusters here as 2. Then we after that, we assign corresponding classes applying SVM for each dataset of each cluster. Then let's assume data in cluster 2 is assigned class with low classification accuracy. Then we extracted data in cluster 2 and apply FCM and SVM to the extracted data. In fact, we iteratively apply FCM and SVM to subclusters that has low classification accuracy as previous iteration. And the flowchart below shows the reclassification process by the reliability score-based classifier. So after the class assignment by the combined method of FCM and SVM, we extracted a matched data and reassign corresponding classes to extracted data by the reliability score-based classifier. And then I'm going to talk about fuzzy simviz method, which is one of fuzzy clustering methods. In fuzzy clustering, each data can belong more than one cluster, whereas such as data can belong only one cluster in hard clustering. Therefore, we can utilize the degree of belongingness of data to clusters in fuzzy clustering. The purpose of fuzzy simviz method is to obtain U and V, which minimize this object function J, and where Xi is ith object, Vk shows the center of cluster K, and Urk is a degree of belongingness of ith object to cluster K, which satisfy these conditions. Is parameter which controls fuzziness of the fuzzy clustering result, and the K is the number of clusters, N is the number of objects, and P is the number of variables. And the algorithm is shown as below. And this is essentially alternating optimization of U and V. And as Tubeck algorithm runs word association from a given dataset utilizing a neural network model based on the idea of neural probabilistic language model. And it produces a vector space, and each word in the given dataset is assigned a corresponding numerical vector of a word in the produced vector space. And the SVM is a supervised machine learning algorithm for classification. And SVM performs a nonlinear classification, transforming input data into a higher dimensional space and obtaining values of the inner product between the data in higher dimensional space using kernel trick. And the right side picture shows the transformation of input data into higher dimensional space. We define the reliability score of J's object to class K like this. And the blue part shows the relative frequency of object J to class K, and the orange part shows the classification status of object J over the K classes. The reliability score was defined considering both probability measure and fuzzy measure. The probability measure shows the uncertainty from data, and the fuzzy measure shows the uncertainty of the human cognition for coding the data. And where T shows T norm in the statistical metric space, and PJK is relative frequency of J's object to class K, and G and J shows a weight for control size of object J. And then I'm going to talk about the detail of proposed method. So first, we tokenize each text description into words. And next, in step 2, we obtain the numerical vectors corresponding to word applying word to Beck. So each unique word in the dataset is assigned a corresponding numerical vector. In step 3, we normalize each feature of the obtained set of numerical vectors. Then in step 4, we produce sentence vectors for each text description based on the normalized numerical vectors. After that, we apply fuzzy simviz method to sentence vectors to classify them into several clusters. And then in step 6, we assign a corresponding class applying SVM for each dataset of each cluster. After that, so we extracted dataset that assign the classes with low classification accuracy for next iteration. And dataset assigned class with high classification accuracy are accepted as classification result. Then we iteratively perform step 5 to step 7 to the extracted dataset until obtaining sufficiently better result. And in step 9, we extract unmatched data. And in step 10, we implement reclassification based on reliability score to the extracted data. So for the numerical example, the family income and expenditure survey data set is used. So we have about 810,000 instances or sentences consisting of purchased item names in Japanese and corresponding classes, and around 520 different codes available. So we have developed a proposed method in Python, but we have confirmed our Python code done in R utilizing reticulate package. So reticulate package provides a comprehensive set of tools for interoperability between R and Python. So the above table shows the classification accuracy of SVM for each dataset obtained from the result of fuzzy simviz clustering at first iteration. So the classification accuracy of dataset in C1 cluster is 0.858, whereas the classification accuracy of dataset in C2 cluster is 0.917. So therefore, we accept the classification result C2 cluster as classification result, and we implement second iteration to data in C1 cluster that has lower classification accuracy. The middle table shows the classification accuracy of each cluster in second iteration. And the classification accuracy of C11 cluster is 0.788, whereas the classification accuracy of C12 cluster is 0.898. Then we implement third iteration to data C11 cluster. The table below shows the classification accuracy of each cluster in third iteration. And the classification accuracy of C111 cluster is 0.837. Whereas the classification accuracy of C112 cluster is 0.764. Then we implement further iteration to data in C112 cluster that has lower classification accuracy. So the above table shows the classification accuracy of fourth iteration. In this numerical example, so we stopped at fourth iteration. The middle table shows the summary of classification accuracy of the proposed multi-class SVM by fuzzy simviz method. The classification accuracy of proposed method is 0.871 finally. And in addition, when combined multi-class SVM by fuzzy simviz method and the reliability score, the classification accuracy is 0.922. And that is better than the classification accuracy of the previously proposed method. Almost 250 data was increased for the correctly assigned. The number of increased terms is not so large. However, the accuracy of the previously k-means assigned has already over the 0.9 accuracy. And this means the terms which classify easily to a code has already assigned and only remain the difficult terms to be classified. So considering this matter, successfully classified such difficult 250 terms to the correct codes shows better result by the use of fuzzy clustering. And furthermore, in the previous proposed method, the k-means method needs many clusters to obtain such a better result. So here is a comparison of classification accuracy of SVM by fuzzy simviz method and SVM by k-means method. The above table shows classification accuracy of SVM by fuzzy simviz method, and the table below shows the classification accuracy of SVM by k-means method.
Yukako, you have about a minute left.
Yeah. When we apply SVM by fuzzy simviz method, the classification accuracy is 0.876 with the number of clusters 2. Meanwhile, when we apply SVM by k-means method, the classification accuracy is 0.862 with the number of clusters 10. So from the comparison between these tables, it can be seen that SVM by fuzzy simviz method allows us to reduce the number of clusters while retaining higher classification accuracy when compared with SVM by k-means. So in other words, when we utilize fuzzy simviz method instead of k-means method, data in each cluster tend to remain homogeneously, and the effectiveness of utilizing the cognitive uncertainty for text description data by fuzzy simviz can be seen in this result. So we propose a new auto-coding method that is a combined method of SVM and FCM with a reliability score. And our target data is, in this study, is data obtained as received digitally, which include complex representation of text descriptions. In order to deal with the complexity of the cognitive uncertainty in the text descriptions, so our study's significant features today's talk is the inclusion of fuzzy clustering as fuzzy simviz method. So fuzzy simviz method is method of computational intelligence, and computational intelligence is linguistically motivated computational paradigms, theory and design of fuzzy logic, neural networks, and evolutionary computation. The numerical examples show better performance of the proposed method with the family income and expenditure service. And our Python code run in R easily, utilizing reticulate package in R. So thank you for your attention.
Thank you. A very interesting talk and a very interesting idea also to iterate over these classifications.
Thank you so much.
Thank you. And thank you for staying up to give this talk. I know there's a time difference with Japan. There are no questions in the chat, so please ask your questions to Yukako via the chat. I certainly still have would like to discuss more, but because of time, we have to move on to my colleague from Statistics Netherlands, Olaf ten Bos, who will talk about extending data validation with standardized metadata from SDMX registries. Olaf, you have 15 minutes.
Yeah, thank you, Mark. Can you hear me?
Yes.
I suppose so. Okay, I'm going to share my slides. Then this one. So I suppose you see the slide. So my name is Olaf ten Bos from Statistics Netherlands. I did this together with Mark, and actually also financed by Eurostat a bit, the Validat-FOS project, validation with free and open source software. So the talk is about extending data validation with standardized metadata from SDMX registries. So what's that? I want to touch on the following subjects. First, I want to explain a little bit about what is international data validation, sending data from one organization to another. Then I want to teach a little bit, no, not really teach, touch upon what is SDMX and what are SDMX registries. Briefly, data cleaning with R. I suppose in this audience, a lot of people know a lot more about it than I do, so only briefly. And then the subject of this talk is actually to connect the two worlds, the R world of validation with the SDMX world. So, international data validation, what's that? When organizations send data to another organization, and the typical example is a national statistical office sending data to Eurostat, but it could also be another international organization like the European Central Bank or OECD or IMF, then that's called data reporting. And in international data reporting, it does happen that the data that's being reported is not good enough. There are some misunderstandings, there are some things not right. And then it's validated or invalidated actually, and it has to be done again. And that leads to costly retransmissions, or in the worst case, even that at the statistical office, we have to reprocess the data. And this is very expensive. And this is not good for both sides. And this is called data ping pong. So that's the problem. And what's the solution? Simply stated, the solution is to agree on a set of rules on both sides. Rules that validate, that have to be, where the data can be validated against. And these rules are, of course, domain knowledge, so they have to be thought of by statisticians in statistical working groups. In practice, it starts to be much more complex, and there have been a number of projects already working on international data validation. I want to name quickly a few. One of them is has been creating a handbook on validation. You can find it on the Cross portal, and one essential thing is a definition of what data validation actually is. Another one is that a number of data validation principles have been written down. You can see them on the right. And one very important one is that if you do data validation, do it the sooner the better. And in this international context, that means that we do not only check the data when we send it to another organization, but we like to check it as soon as possible. That means within the statistical processes. And in many cases, if we run our statistical processes in R, that means we want to validate the data in R. And another topic was finding the main set of statistical rules that apply to the most important or all international domains. Eurostat did that before. You can find more about it on Cross portal. Talking about these main types of rules. They are here, and we approached them in the previous project where we implemented them already in a generic R package. So this year and last year we wanted to go on and ask the question, could we use internationally agreed metadata, and that's mostly in STMX, to automatically derive this validation rules? So this is what we try to do this year. A little bit about STMX. STMX is, for those that don't know, a standard, a statistical data and metadata exchange. It's run by a consortium of international organizations. There's a website if you want to know more. It has been brought to an ISO standard in 2013. It was adopted as a standard in 2008 at the UN level. There are multiple versions. They just issued the 3.0 version. And what is it? It's a generic information model for multidimensional statistical data. And there's one key aspect that's important in this talk, and that's there's some kind of central data, metadata management. So when sending data from one organization to another, there's a place where we organize all the metadata, let's say the code list, the structures of these data. And these are called registries, STMX registries. This is a screenshot of one of them, the global STMX registry. With a URL, you can have a look at it, and there's a lot of metadata over there. But it's not the only one. There's also one from Eurostat. That's called the Euro STMX registry. It looks different, but it uses the same information model underneath. And there are even more. IMF has one, public, UNICEF has one, and I might forget about others. And an important thing is that some organizations have the same kind of registries internally. So everything that we tell here and that we made is also applicable within your organization if you use this STMX standard. So just an example of how this works in the global registry. If you click on items, then you go to code lists. There are many of them. They have a name and a state, and they also have versioning and ownership. And there's an example of civil status. The thing is that these provide access to many standardized metadata. There are a lot of different artifacts, as they call them. We'll focus here on structures and code lists. And there's mechanisms of versioning and ownership. And we want to use that for validation rules. So we need a generic way to access them. And happily, they have the STMX API interface, the STMX 2.0 REST API interface. If you want to know more, look at this GitHub repo. There's also a cheat sheet that explains it. And what we did in the project is we wrote some R code and Python code to experiment with it. And as with many standards, it's not always completely implemented the same. So there were some slightly different functionalities, but there's another great R package that's called RSTMX. And we use that to approach these registries and to get the metadata. You can find demos of the Python and the R in this repo. So that was the explanation on STMX. Now we turn to the R data cleaning world. This is probably you recognize the book of my colleagues on statistical data cleaning, and actually there are so many very good packages on data cleaning at Cran. And we focus here on the validate package to check data based on validation rules, because we want to check the data at international organizations and NSIs, and we want to do it the sooner the better. So this is one slide explaining about validate. Maybe you know it was explained this morning already, so I will skip that, I think. The thing is that validate confronts, you can confront data with rules, and then you have statistics on it graphically and dashboards, etc. So what we did is to extend the validate package with new functionality. Functionality to connect to these STMX registries and to get a code list from any registry that speaks the standard API. Within an RR session, the results are cached, and there are some functions added in validate, and these are the functions. You can give it an endpoint, retrieve the URL because it has to get the metadata somewhere, and then to get a code list from it. And there are convenience functions for the most important registries, for the Eurostat registry and for the global registry. And then the result is that we want to make it as easy as possible to check against these metadata in the registries. And this is an example. So if you have codes in your data, like an activity code, and it has to be aligned, it has to be listened to the centralized code list for activities, then this is just getting all the code lists in one statement. And with the in operator, you check it, of course. So that's a very natural way and concise way to do a check against centralized metadata. One more bit more advanced functionality. We created a function validator from DSD. Now, what's a DSD? A DSD is a structure in STMX that's a kind of definition of a cube with all the code list in the dimensions defined. And with one statement here, you can create a validator from such DSD from a registry. And what in fact it does is it generates multiple code list rules derived, in this case, from the Eurostat registry. So you see on the right a lot of code lists that it retrieves, and then you can check against them. So the idea is to make it possible to easily integrate these kind of checks in your statistical processes. Okay, I have no idea about time, Mark, but I'll just going to wrap up. I hope it was clear. Wrapping up, the European statistical system does a lot of work on improving international data validation, checking the data on both sides so that we don't have data ping pong. And there's a handbook, there are principles, and there are main type of rules. On the R side, we already have a very rich, let's say, data cleaning ecosystem, and that covers a lot of the today's validation needs, both international rules as well as validation rules within your organization. In a previous project, we already implemented these main types of rules, but then we thought it is not enough, because there's a lot of standardized metadata and you want to integrate that in your validation processes. So therefore, the package now supports checks derived from any version of any code list from any SDMX registry. And this can be the global, the Eurostat or another, or a registry that you run within your organization. It's the same function. It's documented in a new chapter on SDMX in the online cookbook. I didn't mention the cookbook yet. I have an example. I've here, I think it's the data validation cookbook is online. So if you follow this link with a lot of explanation on all the types of checks that are supported by Validate, that's very useful to browse. And there's a dedicated chapter on SDMX. And then to conclude, thinking about next steps, we are very interested if you can use this functionality. So if you have experience with it, you're going to use it, let us know, please. We might extend it with reusing other SDMX metadata. And there might be a relationship with VTL. Well, I didn't explain VTL. That's a validation transformation language, a new standard from the SDMX consortium. If anyone in this audience is working on that, I would be very interested to hear about it. So I wanted to state that. Okay, that concludes. Questions, ideas, suggestions, always welcome with us. Thank you very much.
Thank you, Olaf, and thank you for being almost exactly in time also. Are there any questions? I don't see a question in the chat at the moment. And I would feel it would be too much recursion if I'm going to ask a question. So if anyone wants to take the floor. Okay, if not, then I propose that we move on to the first of two lightning talks, which will be given by CILLIA Charles from Public Health Scotland. Yes, there you are. And CILLIA is going to talk about automating open data publication in Public Health Scotland.
Thank you. Hi, everybody. Can you see my slides?
Yes.
Yep. I'll just start full screen. So I'm Chilla. I'm an analyst at Public Health Scotland. And in this talk, I will give you a very brief introduction into how we automated our open data publishing over the course of the pandemic in the past couple of years using R. To give you a bit of background information, Public Health Scotland maintains the Scottish Health and Social Care Open Data Platform to host all sorts of open data relevant to Scotland. We use a CCAN platform for this. This is a data management system that is open source and it comes with a data API that allows programmatical access to all of our open data on this platform. It's also customizable and comes with a rich search functionality. So it's quite a useful tool for us to use. The platform was started in 2017 and has been growing since. We started with a minimal set of data on this platform. Currently, we are hosting 90 data sets containing 704 resources. So that has increased significantly in the past couple of years. As the COVID-19 pandemic hit, the demand for timely, reliable, and well-structured open data has increased dramatically, which resulted in a need for us to rapidly develop a host of new data sets. These included daily COVID-19 cases in Scotland, as well as daily COVID-19 vaccination in Scotland, and also weekly and monthly data sets covering a range of health topics that were impacted by the pandemic. This resulted in an increase in both volume and frequency of data that was getting published on our platform. To give you a bit of an idea of what this actually means, at the moment we're updating 17 large files on a daily basis, and over 500 files get updated on a monthly basis. This was clearly no longer manageable manually. So we started our initial development phase of switching over to programmatical management of the upload process. Due to its compatibility with CCAN, we started this development in Python, as well as because Python has an existing CCAN API package, which allowed us to develop the test scripts very quickly to be able to see if it would work, how it would work, and to be able to tailor it to our needs. However, after this initial development phase, we switched over to doing the entire process in R, due to how this aligns better with our team's experience and skill set, as well as the wider technical infrastructure available to us at Public Health Scotland. R is widely used by analysts at Public Health Scotland, so this facilitates any collaboration for us internally and just ensures that everything runs smoothly by a wider group of people. We also have the RStudio server environment at Public Health Scotland available for us, which allowed for easy scheduling of scripts to run without manual interaction. So this slide shows what our process looks like at the moment. So every day at 12 o'clock, we have a cron job scheduled to run an R script that checks and validates our data files, just comparing it to the expected format, flagging up any data issues by sending a confirmation email to our inbox. Then at 2 o'clock, we have another cron job running a separate upload script, also in R. This uses the CCAN R package to update the data sets. And upon completion of this upload, it sends, again, a fail or success email to our inbox. So any issues or any errors can be addressed immediately. And the last part of our process is still slightly in development. So at 2:30, we run a separate file completeness checking script just to make sure that all of the records fully updated on the platform. Which brings me to my last point, which is what we're still working on and developing and improving this process. We're working on improving our error handling and to build in automated retries if our connection to the CCAM platform times out or if any kind of error occurs. As well as we've got plans to wrap all of our scripts and functions into an internal R package for public health Scotland that can be used more widely within our maintenance of this platform. This will include the file picking functions that I've mentioned, the diagnostic emails, confirmation emails that we get sent to our inbox, the upload functions, as well as we're working on updating metadata through the API as well. And that concludes my talk. Hopefully I managed to stay within the 5 minutes. And thank you very much for your attention.
Thank you too for a very interesting talk. And I think it underlines also the thesis of our keynote speaker this morning, that we use R in many more places than just for data analysis. There are no questions in the chat, but I would just like to remind everybody that if you want to talk to the speakers, you can also send them a private chat. So please don't hesitate to take this opportunity. I'm sure they're happy to answer your questions. Our next speaker is Susie Jentoff of Stats Norway. And hi, Susie. She will talk about using R in Jupyter for statistical production. Take it away, Susie.
Thank you. Okay, so my name's Susie. I work at Statistics Norway within the Methods department. And I just wanted to share some experiences that we've had in using Jupyter in the last year or so. So the first question is perhaps why would we use Jupyter when generally using R? There's a very good tool called R Studio, which is very good for developing our code and running things. But we have a new IT platform called Dept at Statistics Norway. And these are the tools that the IT department has decided to use. R and Python are the two programming languages. There's no SAS or Starter. It's just R and Python. And at the moment, we only have Jupyter in terms of running code. So that's the primary reason why we have been testing this. Perhaps in future, we will have RStudio as well, but at this stage, it's all Jupyter. So first experiences, so many of the people that are moving to this new IT platform to run their statistical production processes come from a non-coding background. So just in general, learning R can take a while, can be a bit frustrating. We're running courses, both beginner and intermediate level courses in R to try and transition people into the new platform. In terms of Jupyter, people like that there's a common environment. Things look the same, whether they're writing R code or Python code. And people have mostly liked the notebook type environment for developing code. Our IT department is reasonably happy because they only have to deal with one IDE tool at this stage. And just a little example. So this is a production process that we're running in Jupyter, which is sampling for the Norwegian Labour Force Survey. It's just a fairly small task, but it just provides an example. The functions themselves are built into an R package, which is on our internal Git. And then the code using these functions is run through a Jupyter notebook. So in this way, we can document what is happening in the process within the notebook, and it provides a clean environment for those that are running the script. This was done, we've been running this year, and the person that runs the code is now not within the methods department, is outside of that and doesn't have much coding experience, and they were able to run the code reasonably easily and understand what's going on because of the background information that's provided within the notebook. Jupyter documents don't render particularly well in our experience. So in terms of the documentation for the process, we have created still a Markdown type file, and this is rendered directly from the Jupyter notebook to create documentation. So for each sampling, for each quarter that we draw a survey sample, we produce a documentation of which files have been connected together and read in and things like this, and provides summary statistics of the sample file. So this works reasonably well for a small sort of process, but as many probably know, Jupyter is limited to R or Python or Julia within the notebook, so you can't transfer between like you can in an R notebook. It's not particularly easy to run in bigger processes, so trying to run notebooks from outside of it when you've got a large production process isn't all that easy. However, we are using papermill and YAML files in order to steer a large production process. People have been missing a classic kind of sort of data view. So within RStudio, you can click on the data set and get a quick overview of the data, whereas in the notebooks, you don't get this, and there's no overview of the environment, the objects that you have in memory, things like that. We haven't got dash support for R within Jupyter, and also creating packages is not ideal within the Jupyter environment. So while I would say, just in general, that Jupyter works reasonably well for small sort of production processes. It's perhaps not ideal, but it's what we have available at the moment, and it is doable. Thank you.
Thank you. A very clear talk with a clear conclusion, I think. Also, it would be interesting to compare this also with something like RStudio Server, which offers also functionality for running R on a server. Again, I see no questions in the chat directly, so I propose we move on to the last speaker of today. So Mark Padgham is going to talk to us. Mark works at our OANCEA, and he's going to talk about peer reviewing code in statistical R packages, standards, processes, and tools. Go ahead, Mark.
Thanks, Mark. Can you hear me okay?
Yeah.
Great. Nice to be together with you again, Mark, on yet another session online. I will try and make this fairly quick so that we can hopefully finish in time. Jump straight to screen sharing. Is that working now? Hopefully. So, my name is Mark Padgham, and with my colleague Noam Ross, we both work for OANCEA, and we're happy to present this talk on peer reviewing code in statistical R packages, standards, processes, and tools. So start with a bit of background about OANCEA. OANCEA, for those who don't know, has a website at oancea.org, and is an organisation, if I zoom in on the text there, that is transforming science through open data, software, and reproducibility. The subtitle there says we help develop R packages for the sciences via community-driven learning, review and maintenance of contributed software in the R ecosystem. So this talk today is going to be about expanding our peer review system for OANCEA. These first few slides will just simply show the website, and so anybody can look at the website themselves and see exactly what I'm talking about here. But I'll briefly go through that, and anything today on any of these slides are largely based on online resources that are all openly accessible for people to see. So one of the things up in the top title bar says packages, and that's one of our core parts of our mission. We peer review R software packages, and the text there describes them. You'll see down the bottom it's got various categories of packages. If you zoom down, it lists the categories of packages there, and you'll clearly note that statistics is not one of the categories given there for peer-reviewed software from OANCEA. If you look at the software peer review page, which also comes up under packages or projects, On the top title bar there, it has a description of it. In the bold font is the important bit where it says packages contributed by the community undergo a transparent, constructive, non-adversarial and open review process. And down the bottom there's a line, a hyperlink through to our statistical software review project. And if you click on that, it takes you to a description of that, which is the content of my talk today, this statistical software peer review. I won't read out the text there too much. Anyone, as said, is free to look up the website and read that themselves. And you can see the list at the bottom there says we have currently, we're accepting submissions of packages in the following 7 categories of statistical software, with 4 additional categories in the pipes. This entire project was supported by the Alfred P. Sloan Foundation, a project called Expanding Software Peer Review, so that those categories which I showed can now include statistics. The project itself has gone through these 5 main steps, which I'll briefly, very briefly outline for the rest of this talk. The first step was to define what statistical software is. We did that effectively as an empirical exercise by collating about 20,000 abstracts from all major statistics conferences over the past around 5 years and applied a whole lot of natural processing and other computational algorithms to come up with some results that identified primary clusters of what statistics software actually is. These were used to define 11 categories in total. To repeat what I said before, we've currently developed standards for 7 of these, and so can accept packages in these 7 categories. The ones that are that have lines through them on the right side there are categories that are in development, so they will come online in the near future. That's how we define statistical software. The second step was to develop standards for the software. This was the most time-consuming component, and it involved, described at a high level, effectively translating observed practices from a host of software in all those different categories into principles for software, and then to convert these principles into written forms of standards. The procedure then involved a lot of iteration between category-specific standards and general standards, and the removal and refinement of the various standards. The end result, after input from well over 20 individual people, was that we've got a set of general standards for all statistical software, as well as a total of 265 category-specific standards in those 7 categories, which we have developed to date. Each set of standards, both the general and category-specific, are generally divided into these rough 5 subsections of documentation, input structures, algorithms, output structures, and testing. The entire set of standards are in an online book, statsdevguide.openci.org. All you have to remember for any of this is simply openci.org, and it's very easy to find a link to the Stats Dev Guide that lists all of the explicit actual standards. But for the purposes of this talk, I will illustrate a few of them very briefly. They start, for example, with the very first, they start with the general standards, the very first one of which, in the first section of documentation, says statistical software should list at least 1 primary reference from published academic literature. The third one then says statistical software should include a life cycle statement describing current and anticipated future states of development. So these are the kind of things that are in the general standards. The subcategories of each standard given before also said there are algorithmic standards. For example, here, an algorithmic standard G3.0 says statistical software should never compare floating point numbers for equality. A good thing to do, but it's done frighteningly often within our packages, and for packages to be accepted for OpenCI statistical peer review, they should never do that. So these standards aim at producing very high quality software. There are also, as said, category specific standards. Here's one example from Bayesian and Monte Carlo software in the subsection of pre-processing standards that says where appropriate, Bayesian software should implement pre-processing routines to diagnose perfect collinearity, and then in a secondary standard, it should provide distinct routines for processing perfectly collinear data, potentially bypassing sampling algorithms. So those are the kinds of standards that are written. There are more than 300 of them in total. And that's an overview of the procedure by which we developed our standards. The third step was to develop tools to aid software development. So to aid the people developing software for submission to our peer review system. This diagram here briefly shows the 3 main tools used for both developers on the left-hand side and also to aid the software peer review process on the right-hand side. And you see there's some overlap there. The SRR package and the package check package appear in both of them. I won't today talk about the auto test, but I'll very briefly describe those 2 packages. SRR, first of all, is software review rocklets, where a rocklet is a documentation engine for the R language. This package is the package intended to enable package developers to document standards compliance within the software itself. I won't go into details of how that's actually done today, but in effect, you run one single function and get a copy of the entire standards in whatever category your software fits within your actual R code, and they all initially have a tag that says SRR stats to do. You move those standards to the locations in the code where they're addressed and change the tags to SRR stats to indicate that you've complied with them. They are rocklets without worrying about the details. What that means is every time you update the documentation for your package using your Rocksystem 2 package, you get a summary overview of standards compliance within your package that reviewers can also use. And the summary of it has additional functionality that I won't show here, but you can also run an SRR report function to generate a HTML version of standards compliance for the entire package, where it's hyperlinked on GitHub to all of the places in the code where the standards are actually complied with. And the reviewers will then also receive a copy of this online HTML report. So that's briefly the SRR package. The package check package, I'll now briefly show not how the package works, but this is it actually in production. So this session that we're in is automation, and this is automation at work here. This is on GitHub, generated today, so 6 days ago really means 6 days ago here, and you can see our OpenSci review bot at the top, which I'll talk more about in a moment. Depositing a check report for a submission of a package called Git targets, and you'll see there that there's a whole lot of green ticks. So this is the package check package in action on GitHub through automated GitHub processes. And the idea is that packages need to have all green ticks and no red crosses. And when you scroll down, it says at the bottom, at the very end here, editor-in-chief instructions. This package is in top shape and may be passed on to a handling editor. So the point of package check and of all these packages is to get packages at a sufficient state prior to submission that then the jobs of the editors and reviewers are much easier than without these packages, and that software is a much higher quality by the time it's actually submitted. In the middle here, so if you go back there, you can see statistical properties, #1 section in that report, and #2, good practice and other checks. And you can see under statistical properties, it says click to open. And when you do that, you get a brief overview of the statistical properties of the packages. It's entirely written in R code with 15 files, 1 author, 1 vignette. It imports 9 packages. It has 9 exported functions with 23 lines of code on average each, and 96 non-exported functions with 6 lines of code each on average. And all of these details come directly from this package check package. And then down below that, it has a report on statistical properties in relation to all current CRAN packages. So we also have a continually updated database of the statistical properties of all CRAN packages that we use here, and it identifies what we call noteworthy characteristics. As it says up the top there, that's when they're in the upper or lower 5th percentile. So this submission here, you can see it only has one noteworthy aspect, which is doc lines per function non-exported, not exported. So these are the number of lines of documentation for all of the non-exported functions, and you can immediately see by looking for which ones are noteworthy that this highlights that there is no documentation for the non-exported functions. So reviewers can easily sort of focus in on statistically noteworthy aspects of a package. The next section there says network visualization, and it says click here to see an interactive visualization. So this is intended to help reviewers especially to understand how a package is actually built and how the different bits of it interrelate. This is what it looks like. It's an interactive JavaScript visualization, which I won't interact with here. This is just a static map of it. It looks a mess, but if you zoom in on it, you get the idea that you can see right in the middle immediately what the sort of central function is. It says up the top that edge thicknesses are scaled to the network centrality. So the most central function in this whole package is one called target snapshot. So as a reviewer, you know immediately where the kind of central work of the package is done, and the nodes are scaled to the number of times each function is actually called. So that can be used to guide reviewers to understand how a package actually works and how all the bits are interrelated. The final bit is then good practice and other checks, which again has a click to open unfold section that reports stuff like this. This submission, the reason I put that here is because it's our very first perfect submission that's done everything right with our package check package. Everything's green, those badges are green. It tells you all the GitHub workflow results and details all of the good practice results with 100% package coverage and no linked issues whatsoever with the package. So that's the end of our very first package that just got a straight off perfect score from the package check package, which now stepping up very briefly to conclude is part of our OpenSci Review Bot, our automated review system, both for general software submission and for statistical software submission. This is an example of the review system in action, where our current editor-in-chief calls for and assign Adam Sparks as the editor of that particular package, and the bot replies that Adam Sparks is now the editor, and he can call check package, and those checks get rerun, and all sorts of things like this. The review bot, you can also say review bot help, and the review bot will then dump all of the commands that you can potentially issue for the bot itself. So that's the core of our automation process that ties in with our statistical software submissions, as I said, and our normal ones. And please, anybody and everybody who's listening, note that we are having an upcoming community call for ROPensci. We've been doing these community calls, which are online Zoom events that everyone's used to now. We've been doing them for years, since long before any of this sort of COVID stuff started, and they still run. Anybody around the world, anywhere at all, is welcome to attend. The next one is going to be on the 7th of December, and we'll describe our automation processes, exactly the kinds of stuff that's behind this amazing new bot that checks all of the packages that are submitted and controls our entire editorial process. So, only slightly over time now, statistical software peer review process is open and accepting submissions. It's very easy to find online in any search engine. The Stats Dev Guide has all the details of the standards and the procedures for authors to prepare packages, for reviewers to review packages. All of the tools that I've described are at a GitHub organization called ROPensci Review Tools. And once again, please attend our community call on the 7th of December this year. Thank you very much.
Thank you, Mark. According to my timekeeping, you're still within time.
Great.
Well, I think there's room for one question. I was felt a little bit left alone because data cleaning is not one of your statistical categories.
No, that's true. But as mentioned, it was an empirical exercise, and it does come into an awful lot of aspects of standards. There are a lot of things like that where people in a specialty area like data cleaning would say, hey, we should be our own category. Empirically, it just didn't emerge as its own category, but it is covered in an awful lot of the category-specific standards, especially. Most of them have standards for input structures, and a lot of those are effectively data cleaning standards. And you should have no trouble submitting a data cleaning package under the system. In this initial phase, there may be a bit of back and forth about exactly where the categories map onto particular packages, but yeah.
Thank you. Interesting work, I think, also for the official statistics community, because we often work in strongly regulated environments. So and something like this could help.
Yeah.
Okay, thank you once again to all the speakers. I'm going to close the session so people have time for a coffee before we move on to the next session that starts at 15:30 CET on Shiny applications. Thank you, everybody.
Thanks, Noah.
Hello, everybody. We can start now the last session of our conference from today. The name of the session is Shiny Applications. See already today a lot of applications in Shiny, different environment. I think most use now interface for data visualization, and it's very nice to have these tools, official statistics, but not on official statistics. So we'll have two presentations for this session and one lightning talk. So I want to thank you all for the participation, and now let's start with the first presentation. The name of presenter is Joshua from Liber Mobility from Netherlands, and will present Shiny demo mobility scan. So please, you have the floor. Hello. I remember to all participants that we have 15 minutes of presentation, 2 minutes for Q&A, and I wish you good luck.
Thank you. Hi, everyone. Do you hear me well?
Yes.
Okay, excellent. Thank you, Ciprian. Hi, everyone. Thank you for being here. Thanks for watching. My name is Josue Aduna, and let me quickly share my screen. Okay. Thanks for watching. I will present a Shiny app that was developed to foster sustainable mobility under an initiative called Life Mobility. And it runs a specific mobility scan. This will be not technical, but rather interesting as a use case and as a case study. So a little bit of context. What is Life Mobility? Life Mobility is a platform that rewards people for sustainable commuting behavior and helps companies to save money, avoid environmental pollution, improve public health, and save travel time. How this is done? This is achieved through a digital ecosystem that analyzes mobility behavior and generates personalized insights to improve mobility efficiency. So I will quickly go to the website. This is a complete Android, iOS, and web application that in essence provides personalized insights, and the key message here is that sustainable mobility can also be fun, right? And Life Mobility actually rewards it. So going back to the presentation, this Shiny application is intended to complement the full Life Mobility application, and is hosted at shinyapps.io, and makes use of some interactive settings together with Google Maps APIs to provide relevant indicators of impact, generate geographic scans through heat mapping, and create mobility profiles. The main libraries that are used in this application is Shiny for the framework, dplyr for some manipulation, Plotly for interactive visualizations, data table for interactive presenting interactive tables, leaflet for maps, Gmaps distance, which is a package for connecting to the Google Maps APIs for distance and durations estimates for different types of transportation, and the last one, Google Way, for routing from origin to destination. So let's jump right into it. Good. So in terms of the data, for example, one can generate a set of a mobility scan from a set of postcodes for a company or even a municipality, right? So here the application just receives a country, some addresses or postal codes, and then the like a central postal code, and then the employees' addresses. So the app runs all possible combinations and with different types of transports, and then gets the analytical data from the Google Maps APIs. I will go straight to the analysis to save some valuable minutes and load directly the analytical data. So this scan is, for this demo, I chose to sample 500 random addresses in London, for instance, for no other particular reason than being an online open engine generator. And here the analytical data is generated for every single employee and combination, which automatically generates some information about distance and duration. Here we have some descriptives, some percentiles, and for instance, we see that in this case in London, well, an average person travels 11 kilometers and around half an hour of commuting duration, which can extend all the way to an hour, right? An interesting thing about the Google Maps API is that it provides a specific kind of scenarios in terms of commuting duration. So it can be a pessimistic scenario, a normal scenario, or optimistic. But in this case, given that we're talking about commuting times, I mean, it usually happens at rush hour, and rush hour still with you know, remote positions more readily available. Rush hour is still rush hour in major cities. So it also provides some warnings. Sometimes the Google Maps API doesn't find some routes and places or specific transport types. So it provides a little bit of information about that. And that's about it in this section. In the next section, we calculate some benefits of adopting sustainable mobility. And for instance, a specific company could have specific, you know, annual costs. And in this specific case, adopting a sustainable mobility can reduce 72% of annual costs, 76% of annual carbon emissions, well, an infinite increase in burned calories, but that's because the baseline scenario only considers cars, as we'll see, car transportation, and adopting other kinds of transportation like biking, e-bike it's a possibility in certain cases, and with a marginal compromise in time spent in commuting. So how is this done? The way this is kind of customized and calculated is through a set of customizable options. Here are some estimates of costs in terms of using lease cars, private cars, public transportations, and bike in the Netherlands. Well, this is customizable like as an Excel spreadsheet, and the whole application reacts accordingly as you customize those settings. So these are representative allowances, and the baseline scenario, as I mentioned earlier, considers only car transportation, and well, this can also be customizable, but usually, it's kind of the baseline and most comfortable option, but not necessarily the best one in terms of these indicators. So the baseline scenario is compared with a specific profile as an advice, and it considers, for example, employees who are 7.5 kilometers away from work who travel by bike, potentially 15 kilometers away by e-bike, and a specific threshold of car duration. So if the public transportation duration is 1.3 times what you would spend in the car, so it makes sense, it's reasonable to go by public transport. So this generates a very different mobility profile, and this is the way that it is compared right up here in the benefits. And remember these colors, right? Green for bike, yellow for e-bike, blue for public transport, and red for car, because this will be useful in the next section, which generates a heat map of the routes in an actual map. So this generates the routing of the analytical data provided earlier, and I mean, I generated it beforehand so that we don't spend some minutes here processing. I load it, and let's see. Good. So this is London, and this is the baseline scenario, which is only considering cars, and looks quite congested, right? It's all red, and especially in the city center, where this company is selected. But if we consider a more sustainable mobility dynamic, as shown earlier in the advice tab, things look different. I will select here modal split advice, and do you remember the colors? So this is how it looks like if we adopt a different mobility profile. This unblocks the city in many main routes, and as well as reduces pollution, of course, saves money, and possibly some time. And it's also a healthier behavior. I mean, there are some interactive settings which allow us to play around here in the city center, but I will leave that for another occasion. That's all for now from my side. Thanks again for watching. Please let me know if there are any comments.
Thank you very much for this interesting presentation. We already know that these kind of tools are very useful for, let's say, smart citizen in a smart city environment. Right. And of course, we know that the data from a smart city could be a very good source of a data source for official statistics. Let's say an example for using in time use survey as sometimes as a benchmark, sometimes as a I don't know, data validation or whatever computation in order to have much reliable data, or in let's say real time, almost in real time data. So if there are any questions, I'm looking now on YouTube, and
that's a good point.
So for the moment, we don't have any questions from the audience. But if the questions come, you could answer to the chat. So until the end of this session, we have more 20 or 30 minutes to have the questions and to answer to that questions, if you agree.
Yeah, of course. It will be my pleasure. And remember that this is also being used to you know, plan a specific public transport infrastructure, and it's already being used. So thanks again, and yeah, see you soon.
Okay, and one quick let's say remember for every authors of the presentation, you can send us a PDF or whatever presentation, and we put it on the website of the conference in a special section of presentations. And if in your case you have the web link of the Shiny application, of course we can put this web link in order to have it public on our website of the conference.
Thank you.
Good. So we will move on to the next presentation. So now we have reporting presentation, a report on the comparing application for province based on COVID cases in Turkey, of course with R-Shiny. So I invite Cenk Jos from Eskişehir Technical University from Statistics Department to have the floor and to see the presentation. Thank you.
Can you see my screen exactly?
At the moment, no. Let's try again.
Okay, sorry. Now
it's coming.
Okay.
Yeah, we see it. It's okay, perfect. Please.
Thank you. Thank you for having me. Thank you for giving me a chance to present in this conference. My name is Cenk Çöz. I am a lecturer working in the Statistics Department of Eskişehir Technical University, Turkey. My main interests are data visualization, statistical learning, and spatial statistics. I try to use R almost every day, and I am trying to teach with R most of my lectures. So here I developed a Shiny application about COVID-19 cases in Turkey, which includes interactive visualizations and automatic reports. So what was my motivation to build such an application? The first reason is insufficient COVID data sharing for comparison of province-based cases, weekly cases. You have to download the data from the official site, unless otherwise you could not find it in the next week or later on. So as I said, there are no database for all weekly data officially in the official site. Therefore, missing reporting of comparisons time-wise and spatio-temporal-wise in the official site. And here is the link of the official site of Turkish Ministry of Health. So I thought let's build an application for use of everyone. So I developed an application for mostly people without any or limited coding knowledge. And in the late February 2021, the Turkish Ministry of Health suggested new regulations to prevent transmission of the virus. So I was curious about the effects of this normalization procedure in Turkey. And the last one is boredom from quarantine. I need a distraction from online meetings, lectures, and quarantine. So I thought I had better be productive and let's build something. So I want to give you some basic information about COVID-19 experience in my country, in Turkey. I will give you a short timeline, and also I will mention about the precautions that was taken at the time of the study. Unlike in other countries, Turkey mostly adopted partial lockdown applications such as nighttime curfews and weekend curfews. The importance of wearing masks outside, social distancing, and hygiene applications were mentioned. The preferred type of education was online education. And in the late February 2021, Ministry of Health suggested a provincial risk-based normalization procedure. They took precautions according to the risks of the provinces in Turkey. And on the 14th of April, they applied a partial lockdown, and in the 29th of April to 17th of May, they applied full lockdowns, education suspended, and all exams postponed. Now I want to talk about COVID-19 visualizations. Most of the used graphical techniques in the literature are the thematic maps for spatial dimension, line graphs for time series graphs, bar graphs, interactive graphs. We all see dashboards in the official sites of the Ministry of Health, different countries. Also, there are Shiny applications. Lots of Shiny applications were developed to visualize COVID-19 cases in different countries, etc. There are a compilation of these Shiny applications in the given references 1 and 2. The first one is Mine Çetinkaya Rundel, and the second one is a data block called data oversight. I forgot its name. So you can find lots of Shiny applications in these compilations. So why examining spatial neighbors before visualizing cases in Turkey? Because the circulation between cities plays a huge role in the transmission of virus. Also, the cities nearby neighborhood cities have got similar weather properties such as the climate, humidity, temperature, weather quality also. Also, the last one is similar socio-economic properties, the access of people to health, to hospitals, and so on. I use root contiguity in my application for spatial neighborhoods. Here are some examples of COVID-19 visualization. Here you can see a step bar graph to visualize the active cases, recovered cases, and deaths in different countries. Shiny applications are also developed for teaching issues, and here is an example of such application. Here, Walker used Shiny to demonstrate neighborhood type, contiguity types with an example of income clustering. Here, I've got some examples of Shiny applications that I found in the references I gave you. Here's an application of COVID-19 country comparison. As you can see, the main plotting pane is divided into two. First one is a thematic map, and the second one is a trend map, time series map actually. And also there is a time slider that for the user to select the relevant time interval. And here another example of a Shiny application for visualizing the COVID cases. It's called COVID-19 tracker. This one is also developed for visualizing the SARS cases. As you can see, a thematic map with bubble plot, and also there is an inline graph of time series graph. Actually, also this application has got a time slider for user to select time interval. Here in the slide, you see an example of the official UK dashboard of COVID-19 cases called Daily Summary Coronavirus in the UK. As you can see, there are lots of important numbers along with the thematic maps, interactive visualizations, and also with time series graphs. So let's talk about my Shiny application. Package that I used in my application. First one is TMap for thematic mapping. Shiny, of course. SP and SPDEP for investigating neighbor-based case trends. I used ggplot2 for elegant graphics, and also Plotly for interactive visualizations. I use tabs in my application. So my application consists of 4 parts. First one is introduction. Second one is province-based risk classification comparison for 2 weeks cases. The third one is increase-decrease status and increase-decrease percentages. And the fourth one is province and its neighbors weekly trends. So let's have a look at my Shiny application. The first part is introduction part. As my first intention is to develop an application for everyone, especially people without any coding knowledge. So there are directions and information for them to how to use the application. As you can see in the sidebar panel, user can have a chance to upload his or her recent data about COVID-19 cases. And also there are two input selection sections. The first one is for selecting week, and the second one is selecting policy, or selecting policy. User have to prepare a comma-separated value file with a header including week information and only number of cases alphabetically in provinces. So here is my second tab, which is actually the first visualization. I divided the main plotting pane into two for comparison issues. As you can see, you see the color-coded risk classification and number of cases in provinces per 100,000. As you can see from the late February to the first week of the May, all of the cases, nearly approximately all of the cases in provinces increased. The map turned into red, which shows very high risk. And in my third tab, there are a change status and changes in percentages thematic maps. As you can see, there are too many increased cases in lots of provinces, and also you can see in the right thematic map changes according to selected weeks. And in the last, sorry, I forgot to tell you about the automatic reports. According to select weeks, my application gives you an automatic report about which province show if decrease or increase, and the percentage along with them. For example, the first one, according to compared weeks in Adana province, there are approximately 30% increase has occurred. There are 81 provinces in Turkey, so there are 81 automatic reports in my application. And this is the last tab, last part of the application. You have to, a user have to select a province, and when he or she select the province, the neighborhood provinces also shown in the time series graph. You can select, or the user can select the whole data in the system already, so you can compare these provinces cases. As you can see, from the 4th or the 5th week, the cases dramatically increased, and also as you can see from the from April 10 to April 16, the most of the cases were in peak, actually, in most of the provinces. So the spatial relationships is important when visualizing COVID cases. And what are my plans for the future? How can I improve my application? Actually, at first I built the Turkish version of my application, and for the conference and for my improvements, I am trying to improve the multi-language application design. Maybe I use web scraping to get the data from the official site. At the point, I don't have any information about how to web scraping are. I can add a data table for users to see at least the data of the weeks and cases. I used a selection of a province by its spatial neighbor, so I'm going to also provide a selection of provinces by users, that users can select any province that they want. Also, now that this normalization procedure, the Ministry of Health actually quit applying this normalization procedure. So I'm going to use the normal chloroplet map instead of risk-based maps. And also I'm going to increase the number of maps. For example, I'm going to divide the main plotting pane into 4 and etc.
Thank you. You should come to the conclusion, please.
Here are the references that I used, and here are the contact information that you can find the code, my chat address. Also, you can, for Turkish friends, you can find, they can find the Shiny application Turkish version in the given link in the slide. If I have time left, I want to demonstrate a little demonstration of my application. If I don't have any time.
Only 1 minute, please.
Only 1 minute, okay. Sorry. You can load the recent data that I prepared from here, load CSV section, and you can select, for example, only 2 weeks entries. Let's have a look at last recent data. Let's compare the recent data. And as you can see, the recent data also shown red colored risk. So we are still in very high risk in most of the provinces. And also we can select province, a different province, let's say Istanbul here. And let's select the whole weeks. As you can see, graph is going to show on the plotting pane. And again, the neighborhood countries have got similar properties of progress about the cases. So this is all from me. Thank you for your attention. Yeah.
Thank you very much for the presentation. A very useful tool again. Alex KOWARIK from Statistical Austria asked for the presentation, and he thanked you for the presentation and asked if you can publish the link of the Shiny dashboard. You showed the link, but if you could send the presentation to have the presentation on the website of the conference, we will thank you from
I will send it to the presentation slides, and the link is here also.
Good. Thank you. Thank you very much. I think that it was a very nice lessons with this pandemic in terms of awareness of for COVID about the pandemic situation, but could be extended to other health problems in order to have, let's say, a sustainable health in the future. So we'll move on to the last presentation. Actually, it's a 19 talk about automation forecasting of regional macroeconomic series. So I kindly ask Priscilla Espinosa from Universitat de Valencia to have the floor, and I remember that you have 5 plus 2 minutes for Q&A. Thank you.
Okay. Can you see the presentation?
Yes.
Okay.
Very good.
Okay. Okay. Okay, my name is Priscilla, and I start. Good afternoon, everyone. First of all, I apologize for my level of English that is still not quite good. And secondly, I would like to thank the organization for allowing me to give this talk. In this presentation, I will talk about automation of regional macroeconomic forecasting in the case of the Valencian community. Therefore, the talk is divided into several phases: introduction, data, modeling, application develop, conclusion, and future lines. In a changing world like the current one, where every day we face different choices, it's essential to have mechanisms that are capable of automation decision processes. These types of tools are important to address limitations that decision makers face, such as constant reduction of decision times, increased uncertainty in decision making. This uncertainty has increased since the last crisis, 2008 until 2012, and current pandemic. Also, dependence on highlight qualified personnel who carry out the economic forecasting processes. In recent times, the interest of many governments is in updating and modernizing their macroeconomic information system, specifically those related to economic statistics, has increased. For this reason, many of these have directed their policies towards the automation of processes in the economic statistical file, specifically in those related to economic prediction. And okay, what is the solution? The solution is easy. Create an application to automatically obtain estimates of future growth of the GDP from the available information contained in medium-term economic series. Okay, I have the solution. Okay, and for that, what do we need? Something very simple: data. For the construction of the application, we need two data sets. The first set is the historical series of the gross domestic product, GDP, of Spain and Valencian community, okay, obtaining through the National Institute of Statistics. This first set can be provided by the user or the application itself extracts them from the official sources. The second set of data is an economic prediction benchmark made up of the prediction made for Spanish growth. For example, FUNCAS, Oxford Economics, among others. We must mention that this second set must be incorporated by the user in the application. Okay, once we have the data, we move on the modeling phases. In the first place, we carry out the recapitulation, the value, and temporal calibration of the value indices, the unit of measure with which we work. In addition, the program will verify if the series entered automatically or manually are seasonally adjusted and or corrected for calendar effects. Second place, we must define the time horizon until which we want our prediction of GDP to reach. It can be current period, current period and additional period, T+1, etc. And finally, we come to the modeling that we will do through an assembly of prediction through a dynamic model. Okay, the models that were tested have been Beck model, Arimat model, assembly of dynamic econometric models, bar model, dynamic, etc. More models. But first, we use an Arimat model with historical data of GDP, Valencian community and Spain, and later an economic model of dynamic assemblies using the prediction of different organisms.
You have only 1 minute, please.
Okay. Okay, from the execution one of the application, it has been necessary to use the Shiny work. The economic prediction application consists of 3 tabs to highlight. The first of them is the one related to the introduction of the application, this. And the second and main one refers to economic prediction, this, figure B. And third and last one is the one related to the manual of use of it, this. Okay. In the first windows, a text observer where the objective of the application is explained, the framework where it's developed, in this case Valencian community, as well as the company and financing it. And mention is also made of different applications developed aimed at improve the macroeconomic frameworks of Valencian community. Okay. Here we can see a couple of screenshots of application structure, this and this, figure A and figure B, and how it's divided. We could say that it's divided according to the set of data that we must introduce, historical series, this, and benchmark, this. Okay. And next, we can see a brief example of how the application, very quickly. In this example, the historical series, this mark of referencia, have been obtained automatically in figure A. We observe the introduction of the second data set, the benchmark. Okay. In figure B, once the file is uploaded, a pop-up will appear indicating that it has been uploaded correctly. Next figure C, with the 2 datasets uploaded, we see the graphic representation of the series in the main panel and below the data of the series. If we keep going down, we will see the data from the second dataset. And finally, in figure D, we are shown a slider input for the user to select the time horizon of the prediction that they want the application to calculate, as well as a button to access the methodology. And finally, in the last of the application tabs, we can see the application user manual so that the user can make a prediction. And finally, conclusions and future lines. Is automation possible? Yes, but supervised. The dependency on the construction of external file is still necessary, and from the future lines, need for a synthetic indicator capable of showing us the future trend of the economy as a variable to test with our prediction with this application. And then generation calendar regression for optimal situational adjustment of economic indicators in the generation of a synthetic indicator using RGDmetra. And finally, also need to know the reality in the very short term thanks to an application capable quarterly GDP. And finally.
Thank you very much.
Quickly.
Yeah. Okay. Thank you for this presentation. Thank you to all the presenters from this session. So we see that the Shiny application is the, let's say, the present and maybe the future for the dissemination, and to have a friendly environment for analyzing. So I will pass the floor. I will invite now to be chairman to Bogdan Oancea from Statistical Romania for a very interesting section of this conference. So Bogdan, I invite you to have the floor and to also to close the conference for today. Thank you, and sorry for this 4 minutes late.
Thank you very much. Welcome to the last session of the second day of our conference. This session is dedicated to EMOS Coding Labs presentations. We will have 5 presentations from EMOS students, but first of all, I would like to invite Matthias Mezaros on behalf of Eurostat to present the EMOS Coding Labs initiative.
Thank you very much. So I will try to be brief. First of all, maybe many of you don't know what is EMOS. It is the European Master in Official Statistics. It started 2 years ago, the coding lab. We started with the statistics coding project, where in Eurostat, some trainees were working on statistics explained articles to recreate graphs through coding. Then our EMOS colleagues came to us that this could be done by EMOS students as well. It would be a nice experience for them to provide some experience working with Eurostat and working with data. And we started last year with the EMOS coding lab when inviting students to work on the statistics coding project and as well extending to MNO, which you could see today, the output from Marko Ramljak. And now the following of the student feedback, we are here today again when we invited as well, not just the EMOS students, but as well our colleagues from the NSIs, the statistical offices, to provide mentoring help for the students. And now this is the case where we have now that we had several NSIs and several universities work together and then provide some output here today. So first of all, I would like to thank you for the conference organizers for the specific session, for the mentors for their work, and as well for the students, what they are doing now. And let's see what is the outcome of their work.
Thank you very much, Matthias. Now, the first two presentations belong to students mentored by our colleague Mauro Bruno from ISTAT. So I will give the floor to Fabrizio Davide to present the results obtained until now.
Yes, hi everyone. I share my screen. Can you see the screen? Can you hear me?
Yes, we can hear you and we can see your screen. Okay,
perfect. So good afternoon, everybody. Here Davide, Diego, and Arsalan. We are three guys from Coding Lab with ISTAT, so the National Institute of Statistics of Italy. I'm Davide and I'm from Florence. Diego is from Bergamo and Arsalan is from Prague. And all of us are statisticians. I'll introduce you to our work and our novel index for the international trade called Greenness. So the outline of our presentation consists of a brief overview, the data that we use for our analysis, the assumption that we should put inside our algorithm, the Greenness index formula, some interesting results, some limitation of the index, and at the end, the plan for the future. So we use the data of international trade from January 2019 to July 2021. And this data covered all the 27 EU member countries. We use graph theory for the analysis, and we treat the country as a node and an exchange of goods between them as an edge. The weight of an edge can be the distance between them and the quantity of kilogram that the country exchange. We know that this greenness index is an estimation because, for example, after we provide you all the assumptions that we made, the distance between the countries are taken by the centroid and not the root of these two. So we use the COMEX data. COMEX is a database provided by Eurostat on the international trading goods. In particular, we use the transport HS, so the product codes of the harmonized system, and the transport NSTR, so the nomenclature. This is an example of the data frame that we created. So, for example, we have the declarant and the partner, the product code, the values in euros, and the quantity of kilograms, the type of transport, so in this case, rail, sea, and road, the type of flow, so import and export, the date, and the distance between the countries. So at the end, with this information, we have a directed graph. Now I'll give the floor to Diego that explains the assumption of our greenness index.
Thank you, Davide.
We have set a few assumptions in order to create this greenness index. The first one is the emission assumption, in which we have all the types of fuel produce similar amounts of emissions. Then we have the type of transport, and so we consider products transported via air, sea, rail, and roads. Then we have the distance, and the distance, as Davide previously said, is calculated based on the centroidal distance and not on the trade route. And then the last assumption, we set the fuel consumption that is based on the shape of cargo ship, fuel consumption, rate of trucks, train, airplanes, ships, and their maximum capacity in kilograms. Yep. Thank you. In order to better visualize our following results, we used this graph. In this graph, we have two parts. The first one is the node, and the second one is the arrow. The nodes are represented by the country that we focused on, and the arrow are the direction from which the product go from one point to the other point. As we can see from the graph, we have different type of line, and this thick is it depends on the product that is transported between the countries. In fact, as we can see, for example, we have between Germany and the United States, we have a thicker line, instead of France between US, it's less thick. So this means the amount of product transported between the two countries. This graph is useful also for future analysis that we would like to carry on. Okay. Yeah. Well, based on the assumption and the graph analysis, we decided also, thanks for our tutor, we created a greenness index, which is based on different variables. The first one is the C, that is the liter of fuel consumed per hour. That multiplies a denominator, that is the distance between the countries, that is multiplied by X, that is the weight of product being transported, and the denominator we have the velocity of the carrier that multiplies the weight of capacity of the carrier. Now, with this index, I let the floor to Arsalan to show you the results and the limitation of our model.
Thank you, Diego. I would just like to say again that this is not the final how the final index will look like, because right now the index is totally dependent on the total weight that is transported. In the future, we would like it to depend on the proportion of the weight that is carried through different types of transport, but I'll get to that later. But right now we can see that what we are trying to present with these two animations is how a certain product, the greenness for each country changes through time. So if we can play the graph, this animation, we can see that we can see how it changes through time for months and for years. For this particular example, we're using mineral oil, which is at the top hierarchy in the COMEX dataset. In their database, there are almost like 100 categories of products at the highest hierarchy. So we can look at either the highest hierarchy, or we can get like we can see individual products as well. And we have one more animation to show in the next slide. This is the heat map. Again, we can here also see if we play it. We can see how this index will develop through time. So if there's some sort of event, whether it is local or global, we can compare how the index looked before and how it looked after for a certain country or different countries relative to each other. And in the next slide, we would like to talk about the limitations. So the first is something that already was alluded by my colleagues previously, which is that we use centroidal distance and not the actual trade routes. And the other is that this index does not take into account what the effects of the emissions are to the immediate surroundings. A good example of this is that ships which are considered to be more green can cause damage to the ecosystems within the sea. So for example, we hear a lot about coral reefs in the news, and also scientists talk about it. So this index looks at a global is at a global level and not it doesn't look at the local effects of pollution. So if you can go to the next slide. So the plans for the future that we have is that first of all, we would like to normalize this index. We would like to standardize it in such a way that it ranges from -1 to 1. And I already talked about it. We would like to take the proportion of the weights and not the total weight that was used, that was transferred from one country to another. And we're already working on it. We already developed it. The idea is already developed. What we need to do now is just implement in our code. And what we would like to do is put these animations and these plots into the dashboard that is already there by STAT about the international trade data. So we can go to the next slide. And these are some of the references that we used where we got the data from, and other data as well about the speeds and capacities. And in the next slide. Yeah, we would just like to thank the team at ISTAT for really helping us. We had weekly meetings, and they were really encouraging and giving us feedback and helping us develop our ideas. And I would especially like to thank Mauro, Serena, Fabrizio, and Francesco for helping us throughout these last couple of months. And yeah, I would just like to thank ISTAT and Eurostat for organizing this coding lab, because I can speak on behalf of all three of us that this was a really positive and enriching experience for us. And yeah, I think that is all. And thank you for your attention. And if there are any comments or feedback or any questions, we would be happy to answer. Thank you.
Thank you very much. You have a question. If you can see the chat, is there a correlation calculated between C and D in the greediness index?
I don't understand the question fully. If someone can maybe explain it.
Can you explain?
Yeah, sure. No, essentially my question was, sorry, am I audible?
Yeah, yeah.
I am audible. Yeah, so basically my question comes from the idea that since C would be a function of D and X, you know, the amount of fuel you would use depends on how much your ship travels or and so on. So I just wanted to know if there was some correlation, if you calculated a correlation between C, D, and X before you, you know, approximated the formula for greenness.
Not really, but we do understand, as I said, that the higher the quantity is, the higher the index will be. This is a limitation right now that we're working on, but this is a very good point. We would also look into this because yeah, it makes sense. So yeah, thank you for that.
Okay, thank you very much. Let's move now to the second presentation, mentored by our colleagues from ISTAT. Elena, the floor is yours. Elena,
Hello, everyone. Can you hear me?
yes, we can hear you.
We can. Okay. Can you see our presentation?
Yes, we can.
Okay. So hello, everyone. My name is Jelena Tijanic, and I'm a student at University of Donja Gorica in Montenegro. My colleagues are Elena Vitti from University TR in Italy and Hakile Razulbegovic from University Donja Gorica, Montenegro. Today we are going to present our work. The topic is time series comparison study using a RIMA model for plastic products trade. So we all know that the plastic is one of the biggest pollutants in the world. The use of plastic products is one of the main obstacles to achieving sustainable goals in terms of green economy. Although a lot of effort is being invested in reducing the use of plastic, it is still at an alarmingly high level. So we choose this topic to see whether the use of plastic decreases over time. This study deals with the import and export of plastic products in EU, and it will forecast on trade in plastic in both primary and non-primary forms to examine whether the trend in plastic use is declining. We consider the data from COMICS database. That's the detailed statistics on international trading goods, and it can be found on Eurostat website. We analyzed the monthly data from period from January 2017 to August 2021. We did the data cleaning part in Python, and after that we analyzed it in R. Since the COMICS data by itself contains a lot of data because of how detailed it is, our primary file had over 22 gigabytes for 5 years period. And it was quite big for our machines. So we made a function to go through all files, clean them, and collect only necessary data. In that way, we reduce size and get a small part of available data. The final output have 5 variables, and that's, as you can see, period, and both export and import value in euros and quantity in kilograms.
After we cleaned our data, we analyzed it in R, and when we loaded in our data in R, we made some graphs. As you can see on the left side, there is a plot which represents export quantity in kilo, and on the right side, there is a plot which represents import quantity in kilo. For this project, we use a RIMA modeling, which is a class of models that explains a given time series based on its past values, but can be used to forecast future values too. For this to achieve, we did explanatory analyze, and after that we got 2 plots with 4 components. The first component presents the observed trends or the actual data plot. The second component presents trends. The third seasons, and the fourth, the last component, present the unexplained parts of our data. Observing these 4 graphs close, or 4 components close, we can see and find out if our data satisfies all the assumptions of our RIMA model. The next step was to remove seasonality from the data, and to achieve that stationarity, we used UniRoot test, and with implementing this test, we got 2 graphs that explains export and import with data without seasonality.
So once that we have checked for the assumption of the model to be satisfied, in particular seasonality, we can determine what are the parameters of our model. So P, the number of lag observation, D, the degree of differentiating, and Q, the order of moving average. So these plots that we can see here are partial autocorrelation plots, and we have done these plots to have an hint and an idea of what could be the value of P, that is the autoregressive part, yeah. And so basically we can see here that we have one significant autocorrelation, and so one parameter to estimate. The next step will be the one of making forecast with our model. Yeah, so before calculating forecast, we have to choose the best ARIMA model possible. The criteria that we used was the AIC criteria. This criteria is like a measure of the goodness of the goodness of the fit of a model. So like the lower is the AIC, the better the model is fit. There is a function in R that we have used that allows us to check for all the possible values of the parameter and then choose the best one, that is the one with a lower AIC. So we have a combination of uniroot test, a minimization of AIC, and a maximum likelihood estimator. And this process is basically repeated over time until we have the best model. After that, we checked for the residuals. So we checked that the residuals have zero autocorrelation. This is very important. And if it is so, and it was in our case, we can calculate forecast. In this case, we have forecast for 5 periods, so 5 months, because months is the unit that we have considered in our analysis. We have export on the left and import on the right. Now we would like to spend some words about what could be further steps in our analysis. So we would like to focus on structural breaks. So we want to see if the parameters of our ARIMA model change during time, and this could be due to some particular scenario like a pandemic, like was COVID-19. So basically in the first step, we will suppose that there are structural breaks during COVID-19, and we will search for that with a CHO test in March 2020. And in the second part, we will not suppose anything, and we will make a data-driven approach. So we will just search for a structural break without supposing anything, and we will see if our hypotheses were true, or maybe if there is something else. Maybe there not was the COVID, maybe because COVID didn't impact the country in the same time and with the same strength, but maybe if it was the obstruction of Suez Canal. And also we can repeat this step for different plastic products, because as Jelena said, the comments data set is so detailed and we have different level of aggregation, and we want to go further into that. And yeah, we just want to conclude our presentation by thanking the ISTAT and the Eurostat team for these possibilities. And we would just want to say that all the people that we met were very helpful with us, and they help us a lot when we have faced some troubles and problems. And also we want to particularly thank Erika, Federico, Serena, Angela, Mauro, and Fabrizio. Thank you so much. And thank you for your attention.
Thank you for your attention.
Thank you very much for your presentation. It seems that there are no questions for you. So we can move to the next 2 presentations. They are related to the use of MNO data in official statistics. This coding lab was coordinated by a team of experts from Spain and Romania. There are 2 presentations. I give now the floor to Vivin for the first one. Please.
Yeah, I'll just share my screen. Can you see my screen?
Yes, we can see.
Okay. Good evening. I'm Vivin. I'm a magistrale in economics from the University of Pisa. I want to thank my supervisors for the EMOS lab, David Salgado, Maria NECULA, Bogdan OANCEA, and Sandra BARRAGÁN. It was a pleasure working with them, and I present here the preliminary results of work with the EMOS coding lab. Working on the simviz package with a simulation offered by Bogdan, David, Marian, and Sandra, I produced 2 functions to help visualize the assessment of cell network data. These form the core of a working paper which deals with the Delaunay triangulation and n-neighbor assessment of the nearest antenna fallacy. All are analyzed using R. The first function, VP plotting, takes 3 parameters, which is the antenna and person CSV dataset, which contain the detail of positions and the list of individuals which one wishes to study. Optional arguments allow you to tweak the final plot which it outputs. The vp.plot function returns the vp partition polygons, which is defined as a tuple of cells rk associated with the points such that the distance, it could be the Haversine distance or the Euclidean distance. This distance is less between the point in the metric space and all other such PJs. So it also plots the VP diagram with the paths taken by the selected individuals, which is the third input. This function allows a complete flexibility in terms of which instance is plot and the complete customization of the plot from the user's end, allowing for very smooth front-end deployment. This is an example plot which is from the data set generated by the simulator that Bogdan and others worked on with a homework split. Notice how the initial positions of the individuals are clustered around two spots, which are the work and the living quarters. So the paths of 4 individuals and the duration of the time of simulation are also mapped. These individuals can be arbitrarily selected by the user. The second example is that of a simulated data set which emulates a Levi flight pattern for the individuals with their initial position being uniformly distributed. Apart from providing front-end friendly plotting mechanism for visualization of the simviz and simutils packages, this function is fundamental to future development of the simviz package and can be used as a building block for future developments. The second function that I contributed to deals with analyzing the neighborhood of each Voronoi cell, which is important in checking for the nearest antenna fallacy. It takes a data set containing the coordinates, which could be Cartesian planar or latitude and longitudes. Optional arguments include options to plot the Delaunay triangulation and the option to return the Haversine distance instead of the Euclidean distance. So depending on what the distance metric is used in the input data frame. The output is therefore the distance matrix of the desired distance unit, the first neighbor of each antenna, the point of such neighbors of each antenna, the great circle or the Haversine distance is returned in the same units that the value of R in the optional unit is entered. By default, this is kept as 6,371 kilometers, which is the average radius of the Earth. The Haversine distance is, of course, the formula which gives you the great circle distance given a pair of latitudes and longitudes as displayed in equation 2. So the output with the plotting returns an appeasing Delaunay triangulation plot, which looks like this, which is essentially what is also used for the Voronoi partitions that you can see in the background are dotted lines. The future implication of these functions are not limited simply to the simviz package, but can be extended to various spatial econometric visualizations. Currently, the research from my end focuses on mapping the cell tower connection location to the ground truth location. I'm working with Bogdan and his group on mapping the cell tower connection location to the ground truth location as provided by the simulated data, and by checking for the cell tower connection distribution to study nearest antenna fallacy. Preliminary results suggest that the simulated approach generates data set which is in agreement to the real world, which contains closest antenna fallacy. However, the assessment packages simviz and simutils are robust to this, which essentially means that they are uninfluenced by the closest antenna fallacy, which makes the simulated data set and simviz and simutils packages better perspective for analysis. So finally, this working paper will allow future researchers to clearly know which data requests to make to the cell network provider for population statistics, and it's a milestone in using simulated data for real-world analysis of big data population statistics. Thank you. These are my references, and if there are any questions, I'll be glad to answer them with the help of my supervisors.
Thank you very much, Vivin, for your interesting presentation. Are there any questions? Okay, it seems that there are no questions, so we can move to the next presentation. Ivana, please.
Share the screen first. Hello, everyone. Okay, I hope you can all see. So I really feel privileged to be part of this group. You can see here the list also of the supervisor that were working with me. So it's Maria, NECULA, Sandra, BARRAGÁN, Bogdan, OANCEA, and David SALGADO. And I would like really to thank them for the whole support given through this process. So the topic that I was working on is methodological development of human movements patterns, analysis using simulated mobile data networks. And it's complementary to what my colleague Vivian just presented. So I will talk a little bit using less technical language. What we were actually working on is how to use the data generated from the mobile networks and how to explore the usage of these data in the official statistics. So what we have from those data is that we know that operators are collecting locations, time, and also some data related to the signal, network, antenna, strength of the signal or the coverage, and that those data are coming in a very complex form and they are not coming as and they are very specific spatio-temporal data, as actually we are not talking about the data based on geolocations, but actually locations are more probability, probability cloud. So we are talking about the probabilities where the device is at the certain moment. Here are the some of the inputs slides that we have given by our dear mentors, and you can see there how complex it is that we have simulated data that are having information on the position, time, and also the antennas which are getting the information of the devices, where the antenna on which devices are connected at the moment. There are many different R packages that we're using in this work. The most important one is SimUtils. The idea is to develop the complementary functions for the SimUtils package that could be used for the data aggregation. Different R packages for data aggregation and also analyzing the trajectories, space containment, and etc. So different R packages were used for different reasons, for data manipulation, visualization, trajectory description, behavioral pattern identification, path reconstruction, space use, characterization, etc. So we were working with the simulated synthetic data, and DA is later to compare the outputs also with the outputs that would be that we can get from the so-called ground truth data. So for the whole population, not the only population that is at the moment connected and having devices that are connected on antennas. And the first step was to do the aggregation of all devices per region. So in the first graph, you can see aggregation per region, and then for the all times, also at one moment on the first second. So you can see the differences that all antennas in all regions are not aggregated in the same level for the different times. And also there is a graph on that's showing the current the density distribution for the, for example, time of first second. So also we have developed the animation of the movements and density for the period of, for example, 900 seconds, so that we can see how devices simulated, the synthetic data simulated devices are moving through time and through different regions, and also how the density of their locations are also fluctuating. We did some further visualization of the density, showing that there are some interesting information that we can get from the intensity of the density. When you can see here, for example, if we increase the if we increase number of grids in the density plot, so when we increase the resolution, we can have the idea for the real data where, for example, main traffic routes or where main places where people are gathering, like campuses, schools, shopping malls, etc. We also can get a lot of information of when analyzing trajectories, their positions. Here are the simulated positions within the 900 seconds. So there is an idea of the, again, density and the space containment. And also there is one just random position check of one individual device or person. And we also find out that there are some very handy R packages that could be used for analyzing trajectories, like for the speed and acceleration. And for this kind of particular synthetic data, it was more intuitive to use the length of each step per second instead of speed and acceleration. And in the further work, it would be this will be developed further in a way that it or the position would be sampled, or the length time duration would be increased. Analyze the trajectories could be also, when we analyze in trajectory, we also can use it for the classification of the method of travel. When we know the velocity, when we know the speed of movement of the device over time, and we know what is the typical speed of walking, running, cycling, or using car, then we can classify devices in this way. So in this output, you can see that mostly people are walking or using car. Also, that there is there are interesting applications in R that could be for different R packages, where we can use R for calculating space used, so that we know the space containment, and from that we can understand. We can assess if the person is using. Is moving or is just staying in some contained space, like at home or at work. But here in this simulated data, with this simulated data or synthetic data, most of the all people or devices were moving, walking long distance, or being in a car. So so it just showed that in the output that even the smallest area that was used was not that small. Also, there is an interesting usage for the similar purpose of one function of trajectory straightness index, which also again can show us if the person was walking or using other type of transportation, and if we also have an idea if the person is walking within some smaller space, meaning in the building, or just or also the used space is bigger. So this is also, there is another way how we can do that using the estimation of travel range. And I think specifically it's interesting here are the visualization, because it can show us if when, for example, in the case of this trajectory, where person supposedly is using a car, where the points of the where traffic is slow, so where we have, for example, traffic jams, or we have other reasons why there is a decrease in speed for that particular point in space. And and for that time. So this is just the beginning of the work, as the idea is to develop specific functions that will be complementary to the already explained package that is used for analyzing data that we can get from the mobile network operators. The idea is to develop it further in a way that we have functions that would classify devices based on the detected mode of transportation, classify devices by region in which they move, which is kind of already done, classifying devices by the sinuosity of their track, by also their spatial containment area within person moves, within the given time and the region, classify sub-areas used on the and based on the device densities index by time and region, and classify computers by mode of transportation from region to region. Those are some references that are used, and I would like again to thank you for the attention, and again really thanks all the group of our mentors that really provide us a great amount of support. Thank you.
Thank you very much, Ivana, for your presentation, for your interesting presentation, and I hope you will finalize your work within this coding lab. Now, if there are any questions. No, it seems not. So it is time to move to the last presentation. This presentation belongs to the students coordinated by Jules Zaccardi from Eurostat. So I will give the floor now to Armen, Jana, and Federico.
Good evening.
Good evening.
Good evening. Okay.
Dear ladies and gentlemen, please allow us to present our research. The goal was to find patterns in asylum applications of Syrians seeking asylum in European Union. We took advantage of knowledge, especially Federico's knowledge, to display descriptive statistics, and later on Armen dealt with time series clustering by destination countries. Let's start with some general information. According to the latest data, over 4.5 million people immigrated to European Union in 2018, mostly because of family reasons. We focused on asylum applications as we found significant flow to Germany, which is a place with mild immigration policy, and that is why most of the Syrians aim there. In our analysis, there are a few significant breakdowns, which most likely were caused by, which likely caused the migration flows. First of all, the immigration crisis started in late 2010 with peaceful protests against human rights violations, and escalated in a civil war as Syrian army was used to dismiss these protests. In late 2014, Turkey and Jordan stopped accepting new migrants, and a few months later, they also ran out of money, and the conditions in the refugee camps worsened. So in this time period, we could experience higher flows in the European Union. And I would kindly ask Federico to continue in his part.
A web app which is possible to program using R language. It is based on the Shiny package, and it allowed us to present descriptive statistics in a very interactive way. But of course, this is not the only thing that is able to do, but there are a lot of features that it is possible to implement. Now, a very useful feature of Shiny is that it's also possible to upload on servers this application, so we don't need the final user to have R installed. It is also relatively easy to code with respect to JavaScript or HTML, and it's very integrated with other data visualization packages such as Plotly. And we also have a free hosting service as shinyapps.io, which provides some free space. The cons are that it's a bit difficult to debug, and when we get to target tasks, it could be hard to program, and servers could be very expensive when we need more than 1 gigabyte. Now I'll show how the app look like. And this was to investigate asylums in general, but then we focused on Germany, and we saw that the largest share of asylum applicants were from Syria in the period from 2008 to 2020. And this is very interesting and consistent of what we found on the literature. And we also saw that Syria itself sent most of the application to Germany, mostly half of the application in total. And what is missed in this visualization are the dynamics of this migration. And to investigate that, I leave the floor to Armen.
Nope. Can everyone hear me okay? Yes.
We can hear you.
Great, thank you. Hello, everyone. My name is Armen Abagan, and I'll be presenting our work on time series clustering. Next slide. So here we were interested in, of course, the patterns in asylum applications for Syrian asylum seekers. So here we're wondering what kind of patterns in the destinations and timing of asylum applications can we determine from Syrians seeking asylum in Europe. So we explored this by clustering destination countries of Syrian asylum seekers via asylum application flows from 2008 to 2020. And the destination countries that were considered were European countries with at least 2,500 asylum applications over the time period studied, in addition to the UK. Next slide, please. So on the left, we have the raw monthly asylum applications data. And as we can see, there is strong variability in the magnitude of the peaks, which would not result in any meaningful clustering, since we're also concerned with the location in the time dimension of the peaks. So as we can see, a standard normalization that we have on the right, with mean 0 and standard deviation of 1, permits clustering based on the timing of the peaks in asylum applications, which is the goal of our research. Next slide. So for clustering techniques, dynamic time warping is used instead of Euclidean distance in measuring distance between the time series, given its elasticity and overall superiority for classification and time series clustering. In terms of algorithms, clustering based on community network detection, k-means clustering and partition around the medioid clustering was employed. However, due to the sensitivity to extreme values of the k-means clustering, we only focused on community-based clustering and partition around the medioid, which gives us the best results. Next slide. So here are the results of the clustering. To the left, we see the community-based clustering algorithm yields 2 clusters, whereas the PAM algorithm yields 4. So for the community-based clustering algorithm, we can observe a high degree of connectivity between 2 clusters, as evidenced by the red lines and the proximity of the clusters, whereas the PAM algorithm does a better job partitioning distinct clusters. And so the highlighted cluster for the PAM algorithm in a little red box will be our cluster of interest, as we'll see in subsequent slides. So an analysis of the silhouette width, which tells us the proximity of a point to its own cluster, indicates that 6 elements are clearly well clustered. And this result is consistent with the 2 methodologies, PAM and community-based, which indicates its robustness. Overall, the PAM clustering algorithm yields a higher Dunn index score, which is the ratio of the smallest distance between observations not in the same cluster to the largest intra-cluster distance, and is an indication of more compact and better well-separated clusters. Next slide. So we find that Austria, Belgium, Denmark, the Netherlands, Norway, and Sweden share the most similarity in terms of the timing and magnitude of the peaks for Syrian asylum application flows. From here, it would be interesting to extrapolate the reasons why these countries follow such a similar pattern. For example, Sweden, Denmark, and Norway all had a pre-war population of Syrians. Could Syrian asylum seekers have applied for asylum in these countries to join an already existing community? Do these countries share a similar profile or timeline regarding asylum policies or overall welcomeness of Syrian refugees? Could it be related to the prevalence of English as a second language in these countries? Could it be related to the prolonged surge in asylum applications in Germany that began back in 2013? And these destination countries in the cluster, given their close proximity to Germany, provided another viable alternative for asylum. So these questions would be very interesting to explore in further research and qualitative analysis. Next slide. Here we can see the average time series of the final cluster in yellow, as well as the asylum applications of, for example, Greece in green. And so here this demonstrates a distinctly different pattern for asylum application flows than our determined cluster. For the destination countries in our cluster, prominent peaks are visible for September of 2014 and October of 2015, the height of the refugee crisis in Europe, followed by a sharp drop in asylum applications. A country like Greece, on the other hand, experiences these surges in applications approximately 5 months after, reflective of the aftermath of the March 2016 EU-Turkey deal to shore up Europe's external borders and limit migration into Europe, whereby Greece became less a landing point for Syrian refugees trying to enter Western Europe and more a destination country for asylum. So in any case, such a cluster analysis provides a valuable starting point and introductory analysis for understanding Syrian asylum flows in Europe. So that is the end of our presentation. Thank you so much for your attention. Thank you so much to the organizers for organizing such a wonderful event. And most importantly, thank you to Jules Zaccardi, our supervisor. He was a very valuable resource and a wonderful mentor. So thank you, everyone.
Thank you very much. Very interesting presentation. This was the last presentation of this session. It seems that there are no questions. Let me check the chat. No, there are no questions. Thank you very much again. So we will close the second day of our conference here. Anna, is there anything to be announced for tomorrow morning?
Tomorrow morning, we will start as planned at 9:30, the European Central Time. Thank you for today's contributions, and I wish you to have a nice evening, and see you tomorrow.
Okay, so let's meet again tomorrow morning. Bye-bye.
Goodbye,
Thank you.
everyone.
Thank you.
Thank you. Bye.
Thank you. Bye.
Thank you so much. Thank you.
It was amazing.
Thank you.
Bye.
Goodbye.
Thank you. Bye.
Thank you. You too. Bye.